Hi, everybody. My name is Elliot Parsons. I'd like to welcome you to the inaugural Coconut Rhinoceros Beetle Science Symposium. We're really excited to have you here. There's been an incredible response to this symposium. We have had about 370 registered participants, and we're really excited that you've taken your afternoon to join us and learn about Coconut Rhinoceros Beetle in the Pacific region. Our goals for this symposium are really to elevate this issue and to share knowledge across the region in order to increase the effectiveness of prevention, management, and control of invasive coconut rhinoceros beetle in the Pacific region. We have 18 speakers across many time zones that range from the East Coast to Hawaii, to Guam, to the Philippines, and Canberra, Australia. They'll be joining us today and tomorrow. Our sessions over the next couple days are going to include topics including monitoring and management, emerging research, communication, detection, invasion pathways, genetics, and more. And when we were putting this together, we wanted to try to address CRB across the entire invasion curve. And so the talks were very targeted. We're going to have as well an extended question and answer session that'll be tomorrow at the end of day 2. And so we really hope that you'll all be able to join us, not just today and tomorrow, but for that Q&A session as well. This has been a really large planning effort and was spearheaded by the Coconut Rhinoceros Beetle Response, the Big Island Invasive Species Committee, the Micronesia Conservation Trust, and the Pacific Regional Invasive Species and Climate Change Management Network. And I'd like to do introductions of our planning and implementation team for this CRB Science Symposium. I'll start with myself, and then I'll pass the torch over to Franny next. My name is Elliot Parsons. I'm a specialist with the Pacific Regional Invasive Species and Climate Change Management Network at the University of Hawaii at Mānoa through the Pacific Islands Climate Adaptation Science Center. Really excited to be here, and I'll pass it over next to Franny.
Aloha, everyone. I'm Franny Brewer. I'm manager of Big Island Invasive Species Committee. We are here, the largest island in the Hawaiian Island chain, and just recently got our very first detection of coconut rhinoceros beetle. So we're in that early stage of that invasion curve that Elliot talked about. And I've been turning a lot to our expert here in Hawaii, who I will turn it over to introduce himself, Keith.
Thanks, Franny. Yeah, I'm Keith Weiser, for those of you who don't know me, and I run the CRB response for Hawaii. And I guess before we continue on, we can have Andrea introduce herself as well.
Hi, good morning, everyone, or good afternoon, wherever you are in the world. My name is Andrea Blas. I'm based in Guam, and I work with the Micronesia Conservation Trust, as well as managing the CRB management programs at the ports of entry here in Guam, working with the Guam Department of Agriculture and Biosecurity Division. And back to Keith.
All right. Yeah. Thanks, Andrea. Thanks everybody for coming. And Elliot said it was spearheaded by all of us, but I think Elliot was probably the one who started most of this. So I feel like I'm kind of along for the ride. So thanks everybody for organizing this. So in our first session, we have Aubrey Moore and Roland Quitugua. First up is Aubrey, who is an emeritus professor of entomology at the University of Guam. And he's been working with CRB for quite a long time in looking at many different aspects. And today he's going to share some of his the history and perspective and talk about the invasion and some of the biology as well. So Aubrey, if you want to get started.
Thanks, Keith. Can you see me? Can you hear me? Okay. Thanks to the organizers for inviting me. I'm really interested in the rhino beetle, and I'll be online for the whole conference because I'm retired. I don't have much else to do. So I decided to focus on CRB biology. A lot of this is going to be review for people here, but there's certain aspects of the biology that really have to be understood in order to handle this problem. So I guess I got to share my screen, right? Yeah, I'd like to thank my financial supporters, funding officers of various departments, the U.S. government, legislature of Guam, for many years of work on rhino beetle. Here's an outline of what I'm going to be talking about. There's a lot there, so I better keep moving. First of all, taxonomy.
Oh, Aubrey, we don't see your screen yet.
Oh, sorry. It is shared. It should be shared. Share
No,
screen.
nothing's being shared yet.
All right, all right. I see what the problem is. Desktop one.
Okay, we see Eve now.
All right, good, good, good. I'm going to back up just, well, no, I'll start here. Let me introduce you to Eve. Eve is a coconut rhinoceros beetle. She's a female, obviously. You can tell by the fuzzy butt. Males have bare butt. Sorry to share this technical jargon with you so early in the morning. So Eve was found on Guam, the first rhino beetle to be found on Guam, almost exactly 17 years ago today. She was found at a waiting chapel doing laps in a little pool there. So coconut rhinoceros beetle is a species of scarab beetle. Just to start out with, there are 400,000 named species of Coleoptera, which is the beetles. The rhino beetle is part of the scarab beetles, 35,000 species. It's part of the family or subfamily Dynastinae, which is the rhinoceros beetles. There are 1,500 species of rhinoceros beetles. So if you're talking about rhino beetles, you got to be very, very specific. She belongs to a genus called Oryctes, and there are 45 species of Oryctes. They all look very similar. And some of them attack coconut trees. So coconut rhinoceros beetle is a common name, which actually refers to several different species. So it's really important to know what you're talking about when you're first invaded. Let's have a look at some of the other Oryctes species. That one, to me, I would say that's a rhino beetle, but it ain't. Same here. Same here. Well, they are rhino beetles. It's just that they're not Oryctes rhinoceros. Same here. Now, believe it or not, this is a Oryctes rhinoceros, really weird looking one that we came across. So the point is, when you pick up a beetle for the first time on an island, you got to get it identified by a professional insect taxonomist. And these days, we actually have some very, very good molecular tools, DNA sequences that can help out in this process. So let's have a look at the geographical distribution. Rhino beetle is native to Southeast Asia, extending out to the Philippines, where I'm talking from. In the early 1900s, it was accidentally moved from Sri Lanka to Samoa as larvae in some rubber plants that were being moved there. During the last century, it moved out into the Indian Ocean and the Pacific Ocean, infested many, many islands. And then in this century, following the discovery of the rhino beetle on Guam in 2007, it's actually infested several islands, both north and south of the equator. The three most recent ones, which happened last year, was Majuro in the Marshall Islands, Big Island of Hawaiʻi, and also Kauai. If we look at a timeline here, we see that the beetle first moved out into the Pacific Islands way back in 1909, I think it was, when it got into Samoa. And then it island hopped and became a huge problem on many of the islands. In the 1960s and 70s, there was a big project that was funded by the UNFAO, and it was managed by SPC, the Secretariat of the Pacific Community. And it was a very, very successful program. The highlight of the program was the discovery of a biological control agent, namely Oryctes rhinoceros nudibvirus, which was a marvelous biocontrol agent. When it was introduced into populations of island infestations, the problem just went away. The damage dropped to very low levels, and the problem was solved. The populations came way down, they crashed. And for about 30 years, there was no further movement of the beetle within the Pacific. And then in 2007, that's when it kicked off again on Guam. So let's have a look at the population dynamics. We'll start with the life cycle. The rhinoceros beetle has 4 life stages: egg, immatures, larvae, which are grubs because they're beetles. There's a pupal stage and then an adult. And the important thing to remember is that it's only the grubs, it's only the adult that does damage. The grubs don't do any damage at all. They feed on dead, decaying vegetation. Any kind of vegetation is fine. It doesn't have to be coconut. They go through this pupal stage where something miraculous happens. Inside that pupal case, the tissues all dissolve into a kind of a soup. The soup reorganizes, and then you get this adult beetle that comes out. Okay, adult females can lay about 60 eggs on average during their adult lifespan. And if we do some very simple mathematics here, we can see that there's a potential for a huge population explosion. Let's say we have one gravid female that lands on an island. Gravid means that it's got eggs, and they actually carry around their sperm with them. So a gravid female is one that has been mated and is carrying eggs. If she lays 60 eggs and they all survive, then we can calculate what the next generation is going to look like. So you take the sex ratio is about 1-to-1 for a rhino beetle. So there's going to be 30 males out of that bunch of the first generation. 30 females times 60 eggs is 1,800 for the next generation. You just keep on doing this calculation over and over again. And by about 8 generations, you have the whole island's full of beetles. Okay, this doesn't happen, of course, because they hit a limit. Food, it's usually food that stops them from exploding like this. But you can see that if there's unlimited food and no mortality within a generation, that there's going to be a population explosion within no time. And that's what has actually happened on some of the islands. It comes in and all of a sudden it's all over the place. All right, so here's a typical habitat for what we call a breeding site. You can see some large third instar larvae here. They're just feeding on all this dead organic matter. In this case, it's a rotting coconut log on the ground. Their favorite breeding site is a standing dead coconut. But you can find them in all kinds of rotting trees, in mulch piles. You can actually go to the hardware store and pick up a bag of potting soil. And if you're unlucky, it will be populated with rhino beetle grubs. In many places, one of the favorite sites is piles of dung from cattle. So here's an urban site that we visited a few years after the rhino beetle came in to Guam. In fact, this is right next to that wedding chapel where the first beetle was found. This is about 2 years after that. We were doing a lot of sanitation. Sanitation means finding breeding sites and destroying them in some way. This is actually a small breeding site. It was about 20 feet long and 4 feet wide. And it was just a planting site, kind of a border where there was a lot of decaying vegetation. Out of this very small site, we pulled out 296 grubs, 41 pupae, and 15 adults. So the importance of the breeding sites is you get all life stages. And if you can control the breeding sites, if you can wipe out the breeding sites, both active ones and incipient breeding sites, you can control the beetle without getting any damage at all, because remember, it's just the adults that do the damage. So sanitation is very, very important. Here is a borehole. This is an old borehole from a beetle that bored into the tree. It's only the adult beetles that do this, and they bore into the tree. They go right through the outside into the white meat, and they're in there for only 3 or 4 days sucking up juice. They're liquid feeders, and they're sucking up the sap. After 3 or 4 days, they'll turn around and come out through that same hole. So they're not really resident in the tree, and they're really not feeding on the leaves. But when they bore into the stem, they will go through developing leaves. And when those leaves actually grow out of the stem and emerge, there's pieces missing. You get these very specific V-shaped cuts, which is very identifiable. So they're not feeding on the leaves. That's kind of accidental damage. They were on their way to the heart meat where they were going to suck up the sap. And that's what happened when the leaves came out. If there are a lot of adult beetles hitting trees very frequently, it becomes a huge problem. You get trees that are heavily damaged like this. And if they actually go through the meristem, which is the growing tip of the plant, which is up in the crown, it's at the base of the crown. It's about, the meristem is only about the size of my fist. But if they bore through that meristem and damage it, then the tree cannot put up a new spear. It cannot make new fronds. So the tree will eventually die. And that's very, very bad because, as I mentioned before, dead standing coconut trees are prime real estate for breeding sites. So in this case here, there's one dead tree in the back here, killed by rhino beetle. These other trees are still alive. And one might think that they're infested with rhino beetles, but that's a misconception. It could be that there isn't a single rhino beetle in any of these trees because they only stay in there a few days and then fly away. So a lot of people think, oh, we got to take down these trees because they're infested. We got to take them down. That's the worst thing you can do. Because if you cut down the tree, it's no longer alive, definitely, right? And you have to get rid of the waste. You have to get rid of those stems in some way. So it's probably the worst thing you can do to take down these trees. These trees could be kept alive using pesticides. Okay, there was something else I was supposed to say, but I've forgotten it. So in the big picture here is that at low population densities, the beetles don't actually do a lot of damage. But once you get a lot of beetles flying around, hitting trees very frequently, they can actually start killing the trees. When that happens, you have a big problem because it turns into a positive feedback cycle. You have dead trees producing, that are used as breeding sites. They produce a lot of adult beetles which fly around and kill the neighboring trees. This has happened on many islands. Here's a picture from Fiji, but we have pictures from all of the islands that were infested in that first wave. And this is happening today on some islands. So very often the beetles will stay at a fairly low population level. And then something kicks off this feedback cycle. In the case of Guam, it was most likely a typhoon. We had a typhoon that hit us in 2015. So the beetle came in 2007, 2015. 8 years later, we had this typhoon. And it didn't kill coconut trees. but it made a lot of dead vegetation in the jungles. There were piles of vegetation all over the place. In the urban areas, there were piles of vegetation. The beetles got in there, and within about 9 months, which is the generation time for the rhino beetle, we had lots and lots of adults flying around. And there were so many of them that they started hitting trees. Some of these trees were mortally wounded and became dead standing trees. And so the cycle changed. And that's still happening today on Guam. Last time I was there, there was still a lot of dead standing trees producing beetles. And this cycle will actually probably die out, but if you're unfortunate, it'll die out when they run out of food, when they've killed all the trees, right? In Palau, when Palau was infested by rhino beetle first in the Second World War, they lost all of the coconut trees on some of their islands, and within the island chain, they lost about 50% of their coconut trees. Okay, so that's one connection to climate change. The prediction is that we're going to have more severe and more frequent typhoons, hurricanes for you guys in Hawaii. So that's going to kick off some nastiness with the rhino beetle. Another connection with the climate change is sea rise. As we know, coconuts protect our beaches. They protect the beaches from erosion. And many of these trees are affected by ocean rise, and they're getting drowned. They don't like wet feet. So here's a picture from, I believe this is Vanuatu. And you can see there's one dead tree here. I wouldn't be surprised if there are coconut beetles in that tree. Here's a more recent picture that I picked up on the net just a few days ago. And this is Majuro. This is one of the most recent islands that was invaded by rhino beetle. Okay, next section's on monitoring. We'll start with pheromone traps. When the rhino beetle arrived in Guam, we didn't know exactly what to do about it. We got some advice from people that said, just put up lots of pheromone traps. You can actually trap out all of the adults, and you can eradicate by just trapping out all of the adults. It turned out that that wasn't true. We made our own traps and got lures, and we put up the traps, and there was no reduction in damage right within the major trapping areas. We were using mass trapping, and it just wasn't effective at all. So Roland and I worked for many years trying to improve traps, and we did improve traps considerably. So we started with these bucket traps. These are traditional traps. Here's a commercial version of that called a panel trap. It's basically the same thing. You hang your synthetic lure up in the trap. The beetles are attracted to it. They bash into these veins, and they fall into the trap, and they can't fly out of the trap. So there's no toxins used in these traps. We actually designed better traps. These barrel traps down here catch about 16 times as many beetles as the old bucket traps. And we also came up with another entirely different technology for trapping beetles, and that's using fishnet. We came up with this idea on Oahu. When we first got there, Department of Agriculture were protecting mulch piles with bird netting, and it was somewhat successful, but a lot of beetles were going right through the bird netting. The holes were too big. So once we got back to Guam, we started looking around at different kinds of netting, and we came across this this type of, it's a very small gill net that the fishermen use on Guam. And it worked beautifully. It works just like a gill net. The plastic falls right down between the pronotum and the rest of the body, and the beetle can't go anywhere. It can't go ahead and it can't go back. These are very powerful beetles. If they were able to get their feet on the twine, they could actually break it, but they can't because they're held by this collar. So this was actually our very best net. Roland went a step ahead and made what he calls a defense trap. A defense trap is designed for hanging on a typhoon fence. These traps caught 24 times as many beetles as the standard pheromone traps. It is a pheromone trap because we hang a pheromone underneath this cup. The idea of the cup is to protect the pheromone from the wind and the sun. And in this case, we actually put a little UV LED, light emitting diode on top. This comes alight at night and attracts the beetles. We increased our trap catch for about three times by using lights. But even this wasn't enough to really put a dent in the population. For some reason, the beetles on Guam were not very attracted to Oryctes, which is a synthetic pheromone. And we did mark, release, recapture experiments, and we were only recapturing about 11% of the beetles, which really does nothing for population suppression. So we stopped using traps for population suppression, but we did continue using them for monitoring the spread of the beetle. At one time, we had 2,000 traps along our roadsides. Similar to what is happening in Hawaii. On Oahu, there are about 3,000 traps on the roadsides. But there's a problem. A lot of people think that trap catch is a linear function of population density, and they look at it as population density, but it isn't. There's a really good theoretical basis for thinking that the relationship is nonlinear, and that it actually starts reducing at very high population levels. It actually goes down to zero. We've seen some evidence of this, and I have a nice little theoretical model, a simulation that I was going to show during this presentation, but I don't have enough time to do that. However, if there's a few minutes tomorrow, I only need about 10 minutes. If there's a 10-minute gap tomorrow, I'd be pleased to show that simulation. Anyway, let's move on. The other way of monitoring is actually looking at damage surveys. As we saw before, the V-shaped cuts are very distinctive. So you can either drive around and look for V-shaped cuts. The next step is taking pictures of those trees and making a database, getting the GPS coordinates. I was trying to automate this process. So I thought, well, let's make a movie. Just put a movie camera on a car and drive around and then analyze each frame using a computer program, using an object detector. So I worked on this about 5 years ago, and we were able to do this. We just glommed a cell phone onto a car and had it take a movie, and then brought it back to the lab, ran it through a computer program that was programmed to find these V-shaped cuts. And it worked, but it took a long time. And the output of this type of survey is a map, damage map. In this case here, we analyzed 900,000 images, and these are full HD images. It took days, but that was 5 years ago. And object detection technology has moved on. Object detectors are much easier to train, and they're much, much faster these days. Oh, by the way, this mapping stuff, automated mapping, can be used in two modes. One is for getting information about an existing infestation, and the other is for early detection. So I sent a phone up to a colleague on Rota after they got infested with rhino beetle, and they did a roadside survey up there and found a new site. Most recently, we did the same thing on Majuro. It took only 4 hours to do a complete survey of the island. My technician drove from one end to the other and back. And he found a ground zero. The ground zero was indicated by V-shaped cuts, and the V-shaped cuts were detected on both sides of the road, going both ways. Okay, since I retired from the University of Guam in November, but I'm still emeritus and I'm still interested in this kind of stuff. So I've learned a lot more about object detection since I retired, and I retrained my object detectors, and now they're fast enough so you can put the whole system on a cell phone. So here's a live demo of a detection system on a cell phone. And this is actually on Google Play Store. I'm looking for testers. Google says that all of their apps have to be tested before they're made public. This is a totally free app. I just want to give it away, but I need some testers. So if anybody's interested in helping me test this, I need 20 good people to just load it onto their Android phone and play with it. Just a comment here. I think we need alternate methods to automate monitoring of CRB populations. It would be great if we could detect individual insects flying around at night. And I think there's ways of doing that using imaging, acoustics, radar, LiDAR, electronic noses for detecting the pheromone, DNA for detecting DNA. Maybe we can get an indication of population densities using some of these techniques. Anyway, let's move on to management. Eradication. Eradication means finding every single coconut rhinoceros beetle on your island and killing it, getting rid of it. The recipe for eradication is it's very easy, actually. You got to locate and destroy all active and potential breeding sites, and at the same time, you got to close the pathways to prevent reintroduction. Easy in concept, but very, very hard to do. Coconut rhinoceros beetle has been eradicated exactly once on a very small island belonging to Tonga, 16 square kilometers. The name of the island is Keppel Island, or Niua Tapu Tapu. This was done in the 1930s, and they did it by sanitation. There was an old German gentleman who took this on as a project. He got the chief's permission to use as much manpower as he needed. And they scoured the island for 7 years, found all of the breeding sites, destroyed them, and the beetle was gone from that island. One and only eradication of rhino beetle. Sanitation is super important. There's two things you got to do. You got to find the breeding sites, and you got to mitigate them in some way. This often means digging them all up and destroying the food and the grubs and adults that are in those breeding sites, or using pesticides. Hawaii's been studying and improving sanitation for a long time. They have the best ideas on this. Detection is difficult. Many of these breeding sites are kind of cryptic. So dogs have been used. Guam was the first place to use detector dogs. They were trained to sniff out grubs with handlers. So this program lasted about 2 years. Dogs are terribly expensive to maintain. There's all kinds of regulations you have to meet. And we just ran out of money. We couldn't support the program anymore. So the dogs disappeared. They actually were retired, and each of their handlers adopted their dogs. Matt Siderhurst and I were talking about finding breeding sites, and we thought, hey, maybe we can use the beetles to find the breeding sites. How can we follow the beetles to breeding sites? Well, Matt had been tracking insects using little miniature radio transmitters. So we got some of these things. We glued them onto beetles, and then followed them around with these little Yagi antennae. Did an experiment on Guam, and sure enough, we could find cryptic breeding sites. And then we thought of another idea. The problem with the radio transmitters is they're very expensive. They're about $200 a piece. They're battery powered, so they're kind of heavy. And they only have a field life of a couple of weeks. And that shelf life is only a year or so. So they're kind of expensive. And then Matt says, well, why don't we use this harmonic radar? It's a different idea. It's just a simple diode with an antenna on it. It doesn't have a battery. The way it works is you shine radio waves onto it, and it sends back radio waves at twice the frequency, and you pick those up. These things are being used in ski gear. They sew these little devices into ski equipment, and the reason is if people are buried by an avalanche, you can run out with this handheld harmonic radar detector and quickly find the person before he drowns in the snow and dig him out. So these detectors aren't that expensive. We got a few of them, and we got a whole bunch of these tags, and we did some work on Guam. We did a field experiment. There were some technical difficulties, so it didn't really work. We didn't recover any beetles, but we're still working on this. Anyway, so the idea is to use beetles instead of dogs, because the beetles are much cheaper and you don't need to train them. Biological control. For insects on islands, biocontrol is usually the long-term sustainable goal, especially with insects that are not on plantations, that are throughout the island. And the best biocontrol agent for rhino beetle is this Oryctes rhinoceros nudibvirus. It was found in Malaysia in the mid-60s, and it was dispersed on islands that were having huge problems with rhino beetle infestations. And as I mentioned before, the problem just went away after introduction of this virus. The way you get it out there is you make a solution of the virus and you actually feed it to adult beetles. And before they get sick, you release them. They fly around and spread the virus throughout the area, throughout the habitat. And the neat thing is this virus is specific to rhino beetles. It's not going to kill anything else. So it's very, very safe. So here's what happened in Fiji. The virus was released, and you can see that the damage, this is a graph of damage versus time. The damage falls to almost zero after a few months, after a year and a half or so. And the really neat thing is this virus stays in the population and keeps the population down. On some islands, the virus has been active for 35, 40 years, and it's still actively keeping the population down. So if you want to stop the beetle from spreading from island to island, you got to get the propagule pressure down, and that means keeping the local density at a very low level, and using the virus coupled with sanitation, you can do that. Okay, so after trying to eradicate the beetle on Guam, we finally got into using biocontrol. At first, we were told, if you're going to eradicate the beetle, don't spend time developing biocontrol methods, because that's going to be wasted time. So that wasn't very good advice, but that was the advice we got. 10 years after the beetle got here, Sean Marshall in New Zealand had been tracking the genetics of rhino beetle throughout the Pacific, and he said, Aubrey, your beetles on Guam are significantly different in terms of genetics. And they had sent over some virus for us to use. We introduced it into the population, nothing happened. So we did some lab tests. nothing happened. We got no mortality at all. So the people in New Zealand who have a library of these viruses, they have isolates. They sent up other isolates. We tested all the available isolates and nothing happened. So Sean said, well, there's an indication that your genetics are different. And this might be the reason why our viruses are not working. So following that, we went out and collected some more virus isolates. But to make a long story short, we haven't been able to control the beetle on Guam with ORNV. We've done many bioassays. This is the last bioassay series that I did before I retired in November. And we tested 4 different isolates, and we got some indication of infection. We did postmortems on the beetles, and some of the beetles were actually infected with virus, but we didn't see any mortal effects, and we didn't see any sub-lethal effects either. So I'm at the end of my talk. Here's some concluding remarks. I like the concept of this meeting. I think we got to work together, share information, and pool our resources. We have limited resources on many of the islands, and we need to work together. And that's the whole idea behind this strategic plan that we put together 2 years ago. It's online. Look it up. It's a really good plan. And I think we got to find some funding for this. So the idea was to have a well-funded, well-coordinated international project, probably hosted by SPC, the Secretariat of the Pacific Community. They have a lot of experience with rhino beetle. In fact, they ran the original CRB project in the last century that was very successful, concluding with the discovery and implementation of ORNV. Okay, I suggest it's way too early to give up on trying to find an ORNV isolate that will control the populations that we're dealing with right now. It's probably a matter of doing some exploration back in the countries where these beetles originated, finding out what viruses are in those populations, culturing them and testing them in a lab, and then possibly releasing them. That takes quite a bit of effort and coordination and funding, and I think we need to do that. I sincerely think that biological control, especially with ORNV, is what's going to be the sustainable solution to the problem that we're now facing. If we can't get a handle on the current infestations, the beetle will continue to spread. And unfortunately, it's spreading onto the smaller islands, the atolls, where coconut is still the tree of life. I mean, people depend on the coconut for everything, for their fresh water, for their food, for their clothing, for their housing, fire, fuel, and copra. They sell copra. That's a major industry on many of the smaller islands. We're not talking about the islands that have plantations here, although that's another problem. And by the way, CRB attacks oil palm. There's lots of money in oil palm, so the oil palm people are really doing a lot of work on CRB, and we need to start communicating with those people a bit better, I think. Anyway, that's the end of my talk. Thank you very much.
Okay, thanks very much, Roland. That was a great talk, and I do have a few notes that regarding questions. Arissa put in the notes. So questions, instead of doing questions at the end of everybody's talk so that we can stay on schedule, we're going to have a Q&A at the very end, and then if there's similar questions in different people's talks, we're going to handle all those Q&As together, and so record all those questions. Yeah, so we're going to try to keep really closely to schedule in case people are just hopping in for specific speakers, so that we don't mess up their schedule. So that's great. So any questions you have, please type them. There's specifically a Q&A section So we'll be monitoring both the chat, the Q&A, and also there was, I guess, a limit. We've hit the limit for this. So if there's anybody who's trying to join, there were some links shared in the chat for how to view this on YouTube, and also the YouTube comments are going to be monitored and included in that Q&A session. So not everybody's question is going to be selected because we've got a lot of participants, but we're going to try and distill down the most common and most relevant questions for that Q&A session that's at the end of tomorrow. So, all right, sorry for that housekeeping stuff. Next up, we've got Roland Quitugua. And he is an extension horticulturalist with the University of Guam. He's been working since the beginning of the infestation on Guam, and so he's going to be talking to us about some methods and impacts today. He's got a ton of experience, so I'm really interested to see what he has to share. So take it away, Roland, whenever you're ready.
Okay. Can you hear me?
Yep, I can hear you.
I can hear you.
All right. Hold on. Ooh. Good morning, everyone. I'm oh wait, hold on. Can everyone see the presentation?
Looks
I
good.
can.
All right. I have this little thing in the middle. So today I'm going to be talking about CRB, but more importantly, who cares? And I say that facetiously because what I'm going to talk about today is basically, I'm going to share my experiences. I was involved with the CRB program here in Guam from the get-go with Dr. Moore, and we learned a lot of lessons. If you want to know what doesn't work, ask me. I'm your man. So what I'm hoping is to share some stories of what we have done, what we have experienced, and I'm hoping that the people in this webinar will be able to identify with particular situations and take those, make it their own, make it applicable. But I also want you to remember that I'm basically using CRB as a case study. And what we're talking about here is applicable across other organisms and other similar invasive situations. So, as Dr. Moore said, in 2007, in Guam, we found a rhino beetle was brought to us. And the first thing we did was identify it. We did a delineating survey and determined that, there's some damage, but we only found one breeding site. So this picture here in the lower right corner depicts what is our tourist district. That's our Truman Bay, similar to Waikiki in Oahu. And we decided, let's go forward and try to do a eradication program, because it looks that we actually potentially have a chance. So Aubrey and I came up with a plan, and I started doing some outreach. Reached out with the public, started taking groups and students out, doing sanitation, and a number of different sites that we identified with damage. We went through and started to clean it up. So we got the community engaged from the beginning. But a couple of things were happening at the same time. In this one instance, I had scheduled a outreach with a group, and I went out one morning and I was doing sanitation along the beach. Sanitation was the one thing we knew worked. At the same time, Dr. Moore was doing a presentation. It was his first presentation to the governor's staff, his cabinet, up at the governor's office. So after I finished with these 30 students, cleaning up, getting everybody, educating everybody, showing them the different life cycles and explaining to everybody what the risk was and what they could do, I ran up and I was able to join Aubrey as he was wrapping up his presentation. And the one thing that I remembered is I walked into the room, just a conference room, and there were about 25 or 30 cabinet members sitting in there, and everybody was doing this, just checking their phones. Nobody was paying attention to Aubrey. So I was observing the presentation at this time. And when Aubrey finished his presentation, the last thing he said is, and when we're done, and if we don't do anything, you know, there's a chance that all the coconut trees will die. And silence in the room. Everybody was numb. So at that point, I chimed in and I said, and when they finish all the coconut trees, they're going to go after the beetle nut trees. At that point, everybody's head popped up. And they were like, what? What are you talking about? So at that point, I knew that when we're talking to people, when we are trying to do outreach, it's very important for us to make sure we understand what is important to the people we are talking to. You see, generally speaking, if you take a look at Hawaii and Guam, how many people actually identify with the importance of the coconut tree? And I can tell you that the majority of the population is probably not much. The people that are on this call are a different breed. The people on this call are a demographic. I'm preaching to the choir here, but this message is not particularly for you, but it's about those who are not in this room. The people in this room see the value of needing to stop the coconut rhinoceros beetle. Now, what was the first thing we did, like everybody else? We did outreach. We did a PR program. We had fancy stickers. We had t-shirts. We were on the radio. We were on the TV. And what happened? After a while, our message started to fall upon deaf ears. And actually, I probably should rephrase that and say, my message was falling upon deaf ears. You see, in the islands, and here's my situation, I hope you're not in the same situation, we have very limited resources and capacity. So just like the Hawaii CRB program, and I repeat, it's a CRB program. When they found CRB in 2013, I was called to help them out. I came over and I was impressed because the first time I walked into their office, they had a full team. They have put together an incident command system. And if you look at that structure, all the different positions in the incident command system was filled. And they all had different names. And that was like, wow, look at these resources. You see, in Guam, we followed the same incident command system. But the difference was 50% of those positions had my name. I was the outreach coordinator. I was the field operations manager. I was procurement. I was involved in research. I was the liaison to the government agencies. So we were, to say, working on a shoestring budget is grossly underrated. And after a while, as I said earlier, my message, and I say mine because I was the one who was out there, I was the face of this, was falling upon deaf ears. So what I did then was I took a step back. And what I've learned is I would identify people in the public who, number one, were interested, and number two, had some sort of connection that might fruit some sort of resource gathering or utilization in the future. And what ended up happening is by spending quality time with key individuals, as opposed to bombarding the general public time and time again, by giving these individuals some in-depth knowledge and educating them on the potential risks, not only to the island ecosystem, but to the culture and not and the environment and the economy. Those people who in their own rights were respected in the community were able to articulate that to the powers that were able to move things, and be it the politicians and the business community, and that's when things started to move. Now, I will say this. When it comes to the Coconut Rhinoceros Beetle, I do not wish it on my worst enemy. My job has been to educate the public, has been to create tools for the public to help themselves, and to prevent the spread of this invasive from moving to the outer islands. Because if I have very limited resources, these smaller islands are going to be in an even worse situation. But on the flip side, was the rhino beetle all bad? Not necessarily. You see, in our experience, because of the rhino beetle, it was a large beetle. People saw it. People saw the damage. One of the things that I had to keep in perspective is when you have a resident who has 1, 2, maybe 3 trees in their yard, and they lose that, they just lose it and say, you know what, we've lost the battle. Well, that means they're the ones who are crying. And they're the ones who are going to be spreading that message around. I had to always step back and look at how the program was going from a 10,000-foot level. And that's why I've kept doing this, because I do see the progress, I do see the advancements, and I do see the value of what we're doing. What the rhino beetle has done is, number one, it had become the face of biosecurity and invasive species for Guam. It was a iconic invasives that people were able to rally around. And because of it, we were able on Guam to pass a biosecurity law. We were able to stand up the Guam Invasive Species Council. We were able to stand up a biosecurity division to help us deal with invasive species and the rhino beetle. And we were also able to pass a fee on all goods coming in to raise funds specific for battling invasive species and trying to get people to add another fee. Every time you're adding and charging somebody something, nobody wants to do that. But there was enough community support for this to be successful. Now, it's not a perfect system. We are still working out the kinks, but it is light years ahead of where we started in 2007. Another thing that happened for us was around this time, we noticed that there has been a renaissance, a cultural renaissance on Guam. There is this movement to re-engage with the native language, the culture, and the practices. And what a better icon or example of why it's important to protect the coconut tree than rally around the need to combat the coconut rhinoceros beetle. FestPat 2016, everybody, all the artisans came out of the woodwork. One of the things that resonated with me was when the artisans were having a difficult time to source coconut fiber and pandanus fiber because of the coconut rhinoceros beetle. For FestPat in Guam, we actually had to import coconut leaves for the festival. And by the way, when the coconut leaves came in, we ended up with a new invasive because we had hitchhikers. Now, the arts and crafts are very important, but do I need to say anything about the food? The food here in Guam, coconut, is very valuable for that. Now, granted, there are mainstream, a lot of people are using store-bought coconut milk, but we still need fresh coconut in a number of our dishes. And the fresh coconut is preferred than the one that you buy in a can at the store. So what is the value in that? That's what hits home. When I have artisans, when I have chefs, when I have people trying to put fiestas together, and they're complaining about how difficult it is to source local coconut, that resonates throughout the community. I'd also like to share that in 2002, I was invited to present at the Pacific Ecological Security Conference in Palau. And this was interesting because the whole idea with this was to develop a CRB plan, a little fire ant plan, and a biocontrol plan. And in the background, we had a bunch of scientists and technical people that have been working probably for a good part of a year to prep some of these plans that have been determined to be important for the Pacific-wide region. But what was critical was not just to develop these plans, but plans are only as good as they are implemented. So these plans were not just for Guam. These plans were not just for the core groups that worked on them, they're supposed, it is the intention of the development of these plans to have wide range applicability across the Pacific. Because remember, in the Pacific Islands, we are only as strong as our weakest link. So when we had this conference, there were over 100 participants. And at the center of this was a table where there were representatives from each of the 10 island countries and territories from around the Pacific. And what I remember is the first couple of presentations were about the science and about the different things happening with invasive species. But as I observed the different country and territory representatives, a number of them did not really know why they were there. I guess is what I should say their faces were like. And what I saw was 10 different individual countries and territories. So my presentation was to bring them together. And what I did was I used the coconut as an example. And the same thing can be said about the participants of this webinar. We are all people across the Pacific. We all use the coconut. Some people, non-Pacific Islanders, can view us, look into the Pacific, and say, oh, we're all the same people. And that is furthest from the truth. The reason why I say that is because while we all have a commonality, and that is the coconut, each of us in our different islands have different traditions, have different uses, and prepare and utilize not just the coconut, but all the different fibers of this majestic tree. That's why it's called the tree of life. And it is those unique uses and traditional practices that we identify with that gives us our unique cultures and identity. And that's the value that I think needs to be recognized and something that we need to be looking at, not just the coconut, but other species when dealing with invasive pests. A story I shared on a number of presentations is one that I'm being asked to share often, is one of my cousin. The lower right-hand corner, you see the bald guy eating coconut. Well, my cousin, Jerry, has been away from the island of Guam for 40 years, living mainland United States in Kentucky. And he came back to Guam and he brought his 17-year-old son who had just graduated from high school. And he was here for a family event. And I went to go pick him up from the hotel. And when he got in the truck with his nephew, who I've just met for the first time, the first thing he said to me was, Roland, I've been telling Orion about the fruit trees here on Guam and growing up and being able to go outside and just eat in the yard. And I'm telling him about how we used to grow up with coconuts and they're everywhere. But when I look around, what's going on? So I told him, you got in the right truck. And I took him up to the university. So when I got up to the university, I had my nephew, I told him, you see that coconut tree over there? climb up it. And so here's this 17-year-old boy looking at me, looking at his father, and he turned around and he tried to climb the coconut tree. Here's a guy born and raised in Kentucky, never seen a coconut tree in his life, and he's struggling to try to climb a coconut tree. So eventually, I reach in and grab a ladder, put him up there, send him up, and I say, Orion, okay. So what the first thing he learned is you need, islanders have certain skills, and you're gonna have to learn that. But right now, we're not doing that. So what I did was I sent him up and I said, that coconut on top of you, I want you to pick it. I want you to hold it, twist it, bring it down. So we did. So that's his experience of picking it. And then I broke out a machete. I cut off the blossom end tip. I grabbed that little piece, the first piece. I gave it to that boy and I told him, hold this. And the look on that 17-year-old's face when he looked at me like, what the heck? And his father immediately jumped in. I said, son, no, you don't understand. Hang on to that. Put it in your pocket. That's your spoon. And this boy was looking at the both of us as if we've lost our minds. So I opened up the coconut. I let them drink the juice, the sweet juice, first time he's ever tried it. And then when they were done, of course, I split it open. And his father goes, son, now take that spoon out of your pocket and do like this, as he showed him how to shred the meat and eat out of the coconut. Now, the reason why I share this is because this experience is something that Pacific Islanders take for granted. I myself am guilty of that. But I will tell you that when Orion and my cousin went home, my cousin wrote to me afterwards, because they were here for 2 weeks. They did every tourist site, they visited every family, they shared stories, everything. But the one thing my cousin said was, of all the things they did on Guam, that experience of sharing the coconut was the one experience that resonated with him. And that is something that we islanders take for granted. What I believe is important for us to remember is that as Pacific Islanders, our cultural identity is rooted in our natural resources. We protect our natural resources. We value our natural resources because of what we do with them, what they give back to us. And therefore, if we want to maintain our identity as a people, whoever we are, it is important for us to recognize that, but we also need to help other people realize the value of our natural resources. Once again, even across Hawaii, across the islands there are differences in all the islands. And a lot of that is based on the natural resources, the unique resources in many instances, and how they are utilized. And we have a moral responsibility to protect that. And that's the value that I see in the work that we're doing. As I have worked with the Coconut Rhinoceros Beetle, I have basically been working on invasive species. That was always what I said. But that's just at the surface. what the truth to what I have been doing for the past 17 years is I have been working on food security. I've been working on island resiliency. I have been working on cultural preservation. Because if we lose a coconut tree to the rhino beetle, we're going to lose a part of our culture. If we lose our farmlands to little fire ant, we're going to lose culture and a lot of our economic sustainability and resiliency. I can tell you now that here in Guam, we just experienced a typhoon just over a year ago, Typhoon Mawar. And I have 3 coconut farmers that have just about given up because of the damage that was not only done by the typhoon, but they lack the resources to do the sanitation and to fully recover after the storm. And the rhino beetle has devastated what was left. So I have farmers who were making like $2,000 a week now can barely make $50 a week to support their family because of the damage to the natural resources. Now, when it comes to the natural resources, I've learned that it's important to break down those silos. A lot of people work in one particular area and ignore the others. When, as Pacific Islanders, we have to remember that our natural resources, our cultural practices, our public health, and our economy are all tied or woven together. Therefore, we have to treat them and give them equal respect. Right now, I challenge each of you who are watching this webinar to ask to take a look and find out, where does invasive species stand on the hierarchy of your island's priorities? That most of the islands, your priorities are always going to be public education, public safety, and public health. And we can even throw in the economy if you want. But where is invasive species? Invasive species is way, way below when it comes to priorities. But invasive species and biosecurity touches all of those. They impact all of those. And for that, it is our responsibility to make sure the powers that be recognize that. Probably the biggest takeaway that I've got is, when I started this presentation, I told you I was doing outreach and people were getting deaf to my presentations and my outreach events. And there was actually one time when a former chief of staff for one of the governors who was governor at the onset of the Coconut Rhinoceros Beetle, I ran into him one day and he came up to me and he was excited and he goes, "Hey, Roland, you know what? You were right." And I was just thinking to myself, what is this guy talking about? He goes, "We should have listened to you." I said, "Excuse me? Listen to me about what?" He goes, "About the rhino beetle. we should have listened to you in the beginning, because now look at it. Man, you were right. And the only thing that I could think of at that moment was, I don't care about being right. My question is, what are you doing now that you've realized the impact and the importance of this? And what did this person do? He walked away. Not with a, I'm going to do this, or now that I know, now that I see it, I can make a difference. And part of this, I believe, stems from the fact that people do not identify with the importance of killing or stopping the coconut rhinoceros beetle. What I've learned that works is that people don't care about the coconut rhinoceros beetle. They really don't. What they do care about is saving the coconut tree. How many times have I and others found green waste, found dead coconut trees, and we go up to these residents, go up to these areas and educate these people and say, hey, you need to remove this green waste because it is a breeding site for the coconut rhinoceros beetle. And what do? They really don't care, because all they see is, oh, you're asking me to move this stuff and I don't have the time and I don't have the resources. But what I have learned is that when I see somebody with rhino beetle damage on their coconut trees, I don't tell them how to kill the coconut rhinoceros beetle. What I do is I let them know, hey, I can't tell you how to kill the coconut rhinoceros beetle, but I can tell you how to save your coconut tree. Now that is what they are interested in. So look at the outreach that's happening now. It's all about killing the rhino beetle. But if you take a look at what's really getting traction, it's those outreach events and opportunities that are built around saving the coconut tree and the traditional practices. So with that, I'd like to say thank you very much. I hope you learned from all my mistakes. Take that, utilize it, make it your own, and have a great day.
All right, Roland, thanks for making all the mistakes for us. But
That's my job.
Seriously, thanks for that. A lot of good information about your outreach insights, Pacific-wide coordination, importance of coconuts and the natural resources affected by invasives. So we're going to take a 5-minute break now. It's 2:24 here in Hawaii, so let's just say 2:30 Hawaii time. We'll start with the next session. So bathroom breaks or whatever you guys need to do. We'll see you then.
All right, hi everybody, welcome back from the break. My name is Elliot Parsons. I'm going to be the moderator for this session, which our first session is going to be monitoring and management. But before we get going, I just want to say a really big thank you to Aubrey and Roland for starting us off and giving wonderful presentations and laying a great foundation for this symposium. So our first session after the break is going to be called Monitoring and Management. And I just want to mention we've got about 200 folks joining us right now, which is fantastic. We do have that Q&A panel at the very end, but feel free to put in your questions in the Q&A as well. So I'd like to introduce our first speaker, Dr. Keith Weiser, who's the Deputy Incident Commander for the Hawaiʻi Coconut Rhinoceros Beetle Response Program. Thanks, Keith, and please take it away.
All right, yeah, thanks for the introduction, Elliot. I'll just dig right in. So what I'm going to cover in this talk is a comparison of sites on Oahu. And looking at the infestation levels, I'm going to show you some trapping data. And as you heard earlier, that's not linear, so I'm going to rely more on the palm and host damage, which is really what we care about anyway. And then there's a bunch of known factors that affect the infestation levels and the host plant damage, but some of the big ones are the green waste treatments that have been done, the land use, the climate in that area, and when CRB was introduced, so how long it's had to grow and proliferate in that area. But there's probably there are a bunch of factors that we don't measure and probably some things we don't know. So things like the effect of predators in that area, diseases, pesticides that are used that I'm not aware of, that I can't report on, and some other unknowns. So those are some things to keep in mind. So the trapping data that I'm going to show you isn't normalized for trap density, so it should just give you a general trend. Don't read too much into those graphs. So what we have here is just a heat map and a map of the sites that I'll be talking about, so scattering around Oahu. And what's really interesting is that we see very different situations in different regions. So there's a lot of regional variability in the impacts of CRB on Oahu. And one thing I'd like to note is you can tell both in terms of the trapping and the impacts if you drive around the island that the numbers of beetles that we find and the palm health, things are looking very good in here. And for those of you who know Oahu well, this is the urban area. So I'll talk quite a bit about green waste, but basically, spoiler alert, the correlation between the amount of breeding material and the impacts is a big factor on Oahu. So also, I wanted to mention earlier that the intention of this information is for people to make good decisions on what the most efficient and the best management practices are going to be for their region and what kind of impacts they should expect going forward. So the first place I'd like to share is the first place that we found CRB. So you can see this black circle down here, Mānoa Bay Golf Course, which is immediately adjacent to Honolulu International Airport and very close to Hickam Airfield. Just looking at the TMK outlines here, or these aren't TMKs, but these are based off of TMKs. We've got Honolulu International Airport, Mānoa Bay Golf Course area, Hickam Airfield, and Joint Base Pearl Harbor. So I'm going to show you some numbers not only from the actual airport, but some of the areas surrounding the airport. But I have separated out the Mānoa Bay information from the airport area, other airport area information. So Mānoa Bay, 1,233 total trap finds. 2014 was the first year that we trapped CRB, and that was the first one that was positively identified, first breeding site and infestation that was identified on Oahu. And through a lot of management, those numbers went down and down, and it was 0 for a couple of years as far as trap finds go. And we do catch some, but it's very well managed in this site. We look at the airport, we see a similar but slightly different trend. And so 413 total finds. Most of these are actually across the highway on the golf course to the north of the airport. So things are actually looking pretty good in the airport area. So let's look at some of the factors that we know that are contributing to that. The palm damage is quite low. We just did a survey of damage on Mānoa Bay Golf Course, where breeding site pulled out more than 1,000 larvae, and then I shared the trapping data of the adults. And we found one damaged tree, one tree currently showing damage. So the green waste and breeding material is extremely low. And as far as treatments, historically, pretty much the only thing I would call a treatment is there was a green waste directive at Joint Base, which they weren't allowed to stage or store trimmings, compost, mulch type material. That all had to be removed from base. And then more recently, we've done some injections around the airport area to prevent hitchhikers and establishment of populations in that area. So the land use in that area is residential and commercial, but there's a lot of paved area and tarmac and areas like that. And the climate compared to other areas on Oahu is a lower rainfall area. So that is probably helpful as well. Another place when back in 2014 or late 2013, but in 2014 when we started looking all around Oahu, Iroquois Point already had beetles. So it had already been established in that area when we started looking for CRB. This is an area where we've done a number of treatments through the years. So you can see these populations or the trap finds are growing. We had 4,384 total trap finds in this area. And we did three rounds of treatments in 2020, 2021, and 2022. There's about 1,000 trees in the area that we treated here. What we see here is that the palm damage now is quite low, and their green waste and breeding material are low levels, and they have a removal program in that area to get rid of all the green waste that's newly generated. And then we had those rounds of injection imidacloprid treatments. Land use is residential. The treatment area that I'm referring to is all residential there. And it's mainly lawns with some beach areas. And then this also is naturally a lower rainfall area, but it's also irrigated to maintain those lawns and the 1,000 palms they have out there. A little bit of a contrast. This is an area that was later infested, and I'll have a table at the end summarizing this information as well. Kunialoa has been some of the highest populations and highest damage and fastest tree death from first infestation to trees dying that we've seen on Oahu. And you can see that that was a later area, later infestation. It wasn't until about 2020 when we started to get significant populations there. We did one round of injections, which took almost a year to treat in that area. So it was probably not that effective because it was temporally spread out. And I think a lot of this, 2024, I should note, of course, we're not done with the data for that. So this is sort of a so far data point, not a full year data point like the rest. We did have some trap reductions in this area, which probably contribute to the lower numbers in 2024. So palm damage is very high in this area. In some properties, 100% coconut death. So green waste and breeding material, extremely high. There are several sites here that are historically green waste landfill sites. We did a round of treatments, as I said, with injections and soil drench that took quite a long time, and it didn't have we didn't cover all the palms. We didn't have authorization to treat since the land use in this area is primarily private agricultural lots. So each individual landowner had to be contacted, and we had to get approval before doing any kind of treatment. So it's a medium rainfall area for Oahu. And of course, because it's agricultural, there's also irrigation in the area. So of the areas that I'll be talking about, this is probably the one with the most severe palm effects. North Shore, so climatically a pretty different zone, a lot more rainfall in this area, and a later introduction. So 2022 is when populations ramped up here, and we also did a treatment in the same year that the detections were there. So we helped a botanical garden there do some of their treatments. So 212 total trap finds. So the trapping is not that high. But there's probably some variability in the efficiency of the traps, especially with the large amounts of green waste in some of these areas. The palm damage there is still moderate, and there's high amounts of green waste. One thing that's notable in this area is that there's a lot of natural area forest surrounding here. And also there's dumping that happens. People will just dump off of the cliffside into the forests as well. So it's not even a situation that's really, you can get any significant control of the green waste. So they have done some injections. We helped with the first round, and then they've been, the Botanical Gardens has been doing their own treatments. But this is a good example of where total green waste control is not possible. So what kinds of effects can you get with treatments alone? So land use gardens and forests, and this is being on the windward side or on the North Shore side, it's a higher rainfall area. Ko'olina is primarily a resort area that's on the southwest coast. So they've had CRB. It was about 2021 when population started to pick up. It was back, I think the first find might have been in 2018, but they didn't really see significant populations until 2021. So over 1,000 total trap finds in this area. The palm damage is low, and similar to the Iroquois Point, they have a removal and no staging of material long term. So they don't keep much. Both there's golf courses and resorts and residential in the area, and they've been opting to go with imidacloprid injections. My group has not done any treatments out there, so this has all been the management and associations for housing associations out there. So this also is a lower rainfall area, but extensive irrigation for all the plantings that they have. Hawaii was one of the first situations on Oahu where we had most of the tools that we have today, and we had a first find with nothing really adjacent to it. So this was a really great opportunity to try out if you had an incipient population and you tried to eradicate it after the first find or two, how that can go. Now we've had that same situation on some other islands. Here's what happened in the Hawaii-Kai area. This is not the whole Hawaii-Kai area. This is a specific part of it, the Inouye area. And so in that area, we had 5 total trap finds. And after the first find, we started working on getting some treatments immediately. We treated immediately with some netting and imidacloprid injections. And it's been more than a year since the last find there, so things are looking good so far. So there is currently no new palm damage in that area, and medium breeding material. There's about a football field sized laydown of mulch in that area, and it's a mixture of residential and agriculture, a lot of nurseries, and this is a moderate rainfall area. Okay. Hauula, sorry, I think I'm going a little long on time. So Hauula, again, windward side, we've got a lot of rainfall there, and this is kind of a worst case scenario because there's no treatment and not a lot of breeding material control. So over 1,400 finds in this area starting in 2022. High palm damage. They have recently cut off mulch import. That was this year. And then some use of netting, residential and agricultural lots, and high rainfall. So this is kind of a summary. And one of the things I'd like to point out is that the palm damage that we're seeing here, a high number is a lot of damage, is not very correlated with how long CRB has been there. It's a little bit correlated with climate, and treatment effectiveness is variable, but the big one is the breeding material. If you have a lot of breeding material, you're probably going to have a lot of palm damage. Even if you were doing treatments, you also need to be working with the breeding material. So, so my big takeaway is control of breeding material is probably the most effective control that's available in Hawaii now, because we don't have a lot of the biocontrols. And then early interventions covering the entire infested area are the most effective. And especially where you can't get green waste under control, an IPM approach where basically you use every tool in the toolbox is what's going to be required to get really good control. So, all right, that's all I've got for you. And thank you for your time.
Thank you so much, Keith. And yeah, you gave us a minute to spare, so that was perfect. Thank you so much for sharing. For our next talk, we have Dr. Michael Melzer, who is a researcher from the Department of Plant and Environmental Protection Sciences, College of Tropical Agriculture and Human Resources at the University of Hawaiʻi at Mānoa. And his presentation is recorded due to his not being able to be present. And so I'm going to turn that over to our webinar host to set that up for us. Can't hear anything yet.
Okay, give me a second. He has a recording on here, so let me try again.
Hey, good morning or good afternoon, everybody. My name is Michael Melzer. I'm a
We got it,
researcher
thanks.
in the College of Tropical Agriculture and Human Resources at the University of Hawaii at Manoa. I apologize for not being able to attend in person. I'm currently traveling and wasn't sure whether my schedule would line up to be able to give this talk. But if you have any questions about the content, please contact me by email. It's listed at the bottom of the screen, and it's just my last name at hawaii.edu. So today for the next 15 or so minutes, I'm going to be talking about RNA interference and can we use this as a component of coconut rhinoceros beetle biocontrol. So RNA interference, this is a relatively newly discovered pathway. It's an endogenous pathway that's active in most eukaryotic organisms. And it's thought to have evolved as a defense mechanism against viruses and transposable elements such as transposons. And we think that these animals or these organisms that possess this pathway have basically adapted it so that they can also use it to regulate gene expression, basically stopping from mRNA transcription to the production of protein. And now that, a lot of study has gone into this mechanism in the last 15 or 20 years, and we understand this mechanism very well now, and we've been able to utilize this mechanism, this endogenous pathway, to specifically target plant pests and pathogens. And a really attractive feature of this pathway is that it can be highly specific to target species, so that we can just use this mechanism to target one species and not others that might be beneficial or just irrelevant to a particular pathosystem or pest system. So RNAi is not something foreign to everybody, especially those in Hawaii. A lot of people in Hawaii are aware of the rainbow papaya, which is derived from 55-1, which is a transgenic papaya developed by a mentor of mine, Dr. Dennis Gonzalez, who's from the Big Island. He did this work when he was at Cornell. But this is a papaya variety that is resistant to papaya ring spot virus. And to sort of show how specific this resistance is that the 55-1 or the rainbow papaya tends to be resistant only to Hawaiian varieties of the virus or Hawaiian strains of papaya ring spot virus. If you were to introduce a foreign papaya ring spot virus or an unrelated virus, these plants would not be resistant to it. So it sort of shows the high specificity. So clearly we've known that this mechanism works in plants, and now we're starting to look at it to target animal pests as well that might attack plants. And here's an example. On the left-hand side, we can see a viral particle and how it might naturally infect an insect. And it basically gets processed, and the insect learns to fight against that virus and tries to prevent infection by the virus. But we can exploit that, and instead of targeting viruses, we can target an endogenous gene. So if we introduce an insecticidal double-stranded RNA into an insect, basically it processes it, and it basically stops protein translation of that insect. And so ultimately that insect is going to suffer. It's not going to be healthy because it can no longer replace maybe an essential protein once the existing protein starts to break down. We're always producing protein to replace existing protein because it does just break down with age. And this is beyond theory at this point. And in fact, some of it's being used in agriculture at this point. For example, SmartStax Pro. This is a new corn variety that uses RNA interference as a pest control mechanism. And it's specifically targeting corn rootworm. Yeah, you're gonna, bottom line is you're gonna see this technology a lot in the future. This is gonna be the future of pest control. We're not gonna be controlling a lot of as many of our pests with pesticides. We're gonna be using these genetic mechanisms that are highly specific to that target and aren't gonna target or damage beneficial insects. So we know that RNAi works against some insects. Does it work against coconut rhinoceros beetle? Several years we looked to examine this, and sure enough, it does work. Basically, we found a bunch of target genes that if we introduced double-stranded RNA that targeted those genes, we got fairly high mortality, if not 100% mortality for many of these within 2 weeks of exposure. So it's not a really fast mechanism. And that's just because if we're stopping protein production, we have to wait for the existing protein in insect to basically break down just due to age. So that's why it can take a week to 2 weeks in order to start seeing mortality, slower than a regular insecticide. But again, it's a much safer option. We looked at this to just see on a dosage side how little dsRNA it would take to kill coconut rhinoceros beetle. And we found that it could be as little as 10 nanograms and probably less. For most of the targets we looked at, when we exposed those second instars to 10 nanograms, just think of that, if you take an aspirin, that's like 200, 500 milligrams. This is, basically a billionth of that we're looking at here with 10 nanograms. Very small dosages. So the big thing with RNA interference is how do we deliver it? In the case of SmartStax Pro, which is that corn variety, or with 55-1 or rainbow papaya or all its derivatives, we modified the host plant by genetic modification. And that was the case in papaya and corn. Nobody I'm aware of is interested in doing that with coconut. So that's probably not how we're going to deliver it. So another way to do this is through application like a traditional pesticide. Basically, you just spray these dsRNAs on the plant, and we wait for the insect or whatever pest it is to either absorb it through the skin or ingest it through feeding. And that works well for some insects, but unfortunately, we've never made this work for coconut rhinoceros beetle. We've tried a lot of different ways to introduce this dsRNA to elicit a response, but we could never make it work. And that basically caused us to shelve this, looking at RNA because none of the existing delivery mechanisms worked in our hands. So for many years, we just ignored double-stranded RNA. But what made us start to reapproach this or re-examine RNA interference is the use of viral vectors. Viruses are basically nature's genetic delivery tool. They're basically just protein coats that deliver nucleic acids into their host cells. Perfect for what we're looking for. And looking for a viral vector, it could be a pathogenic virus that's either been disarmed so that it's no longer a major pathogen or a highly virulent pathogen, or it could just be a non-pathogenic virus. And there's a lot of those out there where viruses are infecting their host, but they don't cause any serious damage or pathology. And viral vectors are familiar to us because we've heard of gene therapy. And we're using viral vectors in gene therapy right now. And there's even therapeutics out there that use virus vectors, treating things like, especially congenital diseases like sickle cell anemia. I think there's a viral vector, an FDA-approved virus vector for treatment. And so this has been, using RNAi for therapy has been around for a long time. This is, a fairly recent article. But again, using some of these viral vectors to deliver, in this case, AAV or adenosine-associated virus. These are, we know some good viruses in humans that we can use to deliver our gene therapy targets. So let's look into the use of viral vectors and viruses just in insect management. Well, just wild type or native viruses, we know we've been using them for a long time for insect biocontrol. A lot of cases, most of the cases are using nuclear polyhedrosis viruses, often targeting Lepidopteran hosts. And here we can see a caterpillar that's been infected by one of these NPVs, and just basically turns it into mush, and usually a very good biocontrol agent. And there are even commercial available formulations that are basically biopesticides available for some insect targets. And then, of course, we've got Coconut Rhinoceros Beetle itself. Coconut Rhinoceros Beetle has been under control in the Pacific for decades due to release of the nudibvirus, which is somewhat related to these nucleopolyhedrosis viruses, but a little bit different. And it's been keeping CRB relatively under control for a long time. I'm sure you've heard some other talks that have sort of discussed about how there's been a few roadblocks or a few bumps in the road, I guess, in using it. But we have been using viruses for biocontrol for a while. You can see this one on the bottom left here, this larva with a prolapsed rectum as a symptom of infection by Oryctes rhinoceros nudibvirus. So I guess, we know that viruses themselves, but can we use them to deliver RNA interference to target insects? And the answer is yes. We first saw this about 10 years ago. This was 2014. A colleague of mine in Florida used citrus tristeza virus, a virus I'm very familiar with. They basically used it as a viral vector to target an important agricultural pest of citrus. This is the Asian citrus psyllid, or Diaphragma citrii. On left is that insect exposed to just regular citrus tristeza virus. On the right, it's a modified citrus tristeza virus that carries an RNA interference element that targets the development of the wing of that insect. And we can see if that gene has been targeted, the wings are deformed. And the thought is that this insect can no longer spread the pathogen responsible for this important citrus disease. But that's a case of, basically that colleague was just using citrus tristeza virus to screen targets. The first example that I'm aware of that uses actually a insect virus is also that same target, Diaphragma citrii, or the Asian citrus psyllid. But this group from Davis, UC Davis, they used cricket paralysis virus. It is actually a pathogen of Diaphragma citrii, but they found if they used it as an RNA interference delivery mechanism, that virulence could be increased. So that got us kind of excited, and we're much more excited when some researchers in Australia and Taiwan identified a new picorna-like virus in Coconut Rhinoceros Beetle. This is probably an ideal situation because this is a small RNA virus, so it's much more amenable for modification and use as a viral vector than the big Oryctes rhinoceros nudibvirus. And it's already infecting Coconut Rhinoceros Beetle. So this virus knows how to infect CRB. And so that got us looking, hey, maybe we should re-examine RNA interference and use this new picorna-like virus, similar to how we use adenoviruses and retroviruses, lentiviruses in gene therapy in animals and humans. And so how this works is basically you're looking at the genome of one of these viruses, and basically you're just starting to insert some sequences that are specific to your target organism. In this case, you see this thing called an insertion site. So this might be a location where we could introduce our RNAi sequences that are specific, that would target Coconut Rhinoceros Beetle into this virus. And then once that virus infected CRB, it would become lethal. Otherwise, a wild type would probably not have a major effect. And so with the genome of this virus known, and this virus has been reportedly detected in Hawaii from some samples that we sent to these colleagues from Australia and Taiwan, we decided this could be a potential RNA interference vector. So what we've done to this point is creating an infectious clone of this, basically a wild type version of the virus based on the sequence from the Australian and Taiwanese group. And at this point, we're still waiting on IBC approval for inoculation. We just need to make sure all the boxes are checked before we do any experimentation, and it goes under appropriate review. So what we're looking to do in the near future, and hopefully by the end of the year, well, one thing we've already done is start a Coconut Rhinoceros Beetle cell line. This is going to be really helpful for maintaining any Coconut Rhinoceros Beetle viruses that we want to work with, because we're using the actual cells of the target we're looking for. In a lot of cases, we're using insect cells of other species to maintain CRB viruses. And then once we get that approval, we'd like to begin inoculations and then modifications of infectious clone. But the one thing we also want to do is examine the infectivity and virulence of other insect viruses present in Hawaii. And this is something we can do in the meantime. We don't have to import anything. We know a lot of different insect viruses exist in Hawaii, so maybe we can artificially inoculate CRB, and some of them might be pathogens. And those could be used to, in a biocontrol system or management system. And then finally, eventually, we want to look into foreign exploration and start seeing if we can find additional pathogens to bring into Hawaii with appropriate containment. And with that said, I'd like to acknowledge the lab, some of the folks that have supported us, the Hawaii Department of Agriculture, Hawaii Department of Land and Natural Resources, and the U.S. Department of Agriculture. This is a very old lab photo. Most of these people are gone, but yeah. But in any case, thank you for listening for me today, and I hope you found this informative.
Thanks so much. I'd like to thank Mike for preparing this talk on this cutting edge research. We're running a couple minutes behind, but we'll catch up during the break. And I want to introduce Dr. Ryan Perroy, whose talk is titled Find the Notch, Developing an AI Detector for CRB Damage Using Drone Imagery. He is a professor of geography and environmental science at the University of Hawaii at Hilo. Please take it away when you're ready.
Okay, will do. Thank you very much, Elliot, and it's a pleasure learning so much about CRB. This is fantastic. Happy to be part of this. Yep, so I'll be presenting a little bit of work that we've started pretty recently, trying to develop an AI detector for CRB damage. And although I'll be speaking, this is really work led by some of the co-authors here, Tori Valdez and Pat Perez, I'll introduce in just a second. And we've been using imagery provided by some great partners from University of Guam and Mānoa, CTAR. So yeah, just want to acknowledge the folks who have been able to provide the imagery that we've been working with, and also this is kind of a side project, but we have gotten some funding to support Tori from Hawaii NSF EPSCoR Change Hawaii grant. So want to acknowledge that. And here is Tori. So she's a current undergraduate at Hilo, and she's really the one who's doing this work in terms of building up the training data for the models from the imagery provided, and then working with developing the models themselves with a lot of guidance from Dr. Pat Perez, who is a researcher in the Hilo SDAV lab, which I'll talk about in just a second. And I also want to acknowledge Erin Weingarten, who's a spatial analyst in the lab as well. She's working on a related project where we're trying to generate an inventory of coconut trees for certainly the coastal areas across Hawaii Island, so we can maybe know where to focus some efforts using some helicopter imagery that we've collected for some other projects. So I'm talking to you all from Hawaii Island, and here at the University of Hawaii at Hilo campus. Beautiful place, although it's a little rainy right now. It's fantastic, and I'm a geographer, so I'm coming at this from the perspective of a geographer. I also am the director of the Spatial Data Analysis and Visualization Research Lab here at Hilo, where we aim to apply geospatial tools to environmental problems of local significance. Also associated with a master's program we have here. So if any of what we're talking about today sounds of interest to you and you're interested in a master's degree, you're more than welcome to contact me. But in terms of motivation, I'm going to show a few maps that have already seen. So Aubrey, Dr. Moore, presented his great work. on some of the damage that able to observe from roadside surveys in Guam. And then Keith had showed this map from all the amazing work they're doing over on Oahu. Here on Hawaiʻi Island, right, we're really, as Franny mentioned earlier on in the initial stages of this, with just a few detections at this point. And hopefully we'll keep it that way. With this symposium is freaking me out a little bit. I'm learning lots of things. And so, my group was trying to think, how could we potentially contribute to this effort? And we do a lot of work with high resolution imagery for detecting different things. Rapid ohia death, strawberry guava. I have a graduate student, Olivia Jarvis, who's working on this, using different essentially convolutional neural networks to learn from training data and then help us detect these things that are of interest. And we have different partners, including Hawaii Volcanoes National Park. This is a Morellifia tree, invasive plant that folks are worried about to help detect in the park. And then our old nemesis, Myconia. And so basically all those little boxes you're seeing there are the computers identified that those are individual Myconia leaves. And so with this background, we thought, the CRB damage in palm fronds, it's pretty striking and could be a really good candidate for this. And again, Aubrey Moore has shown that from ground-based surveys, able to do this great. And I actually have downloaded his app. It's fantastic. But I don't luckily have too many CRB damaged palms around me to test it out, but I've shown it pictures and it's picked that up. But we were interested in doing this from the air, right? From an aerial perspective, you can cover a lot more ground than driving along the roadway. We're not the first ones to look at this. Recently, I came across this publication, some folks in India using deep learning based detection of CRB using drone imagery. They had a slightly different approach where they're focused on whole tree detections, and they're working in sort of a oil palm environment. And so here in Hawaii, it's a little bit more kind of mixed forest that we're dealing with. And the approach we've decided to take is really on the kind of frond level. And so we're looking for CRB damage at the frond level. That's what we're working at currently. Again, on Big Island, luckily at this point, at least, there's not a whole lot of damaged trees that we could build up a training data set from. So we have a great partnership with Romina King and folks at University of Guam, Drone Corps. It's a great program, and they've been able to provide us a lot of imagery from Guam and Palau at this point. So 3 sites on each of these islands, and interestingly, they're from different image resolutions. So this is the crispest imagery that we've been provided. This is less than a centimeter pixel spatial resolution, and you can really see pretty amazing detail in terms of those V-shaped notches. Some additional imagery from Guam. This is now taken at about 200 foot AGL or above ground level. I could talk about camera specs later, but not quite as crisp, and up to 500 foot with their camera, and that's about 1.8 centimeters. I'm not sure if you can see my cursor here, but it's a little bit harder to see some of this damage, but you can still pick it out. And then even higher up. And so, there's a variation in terms of the details that you can pick out. And so we've been playing with all this imagery and trying to generate some different models that I'll talk about. One point to make is that for any kind of, using drones or other systems, you really want to fly as high as you can and still robustly detect the thing of interest, because your efficiencies in the area that you cover goes way up. In this slide, those pink circles are each over a single coconut tree, but you can just get a sense about the area covered in an individual photo at 100 foot AGL versus 600-foot AGL. So if you can detect the thing flying higher, then you'll be much more cost effective and time effective for doing your monitoring surveys. We use a variation of a Python package for airborne object detection and classification called Deep Forest, and Dr. Pat Perez is kind of our resident expert in this, but this is the kind of the backbone of the system that we use, and we've since modified it for some of the work we do in the lab, and specifically for at least what I'm talking about today for CRB detection. So Tori has spent the last summer annotating photos and working with Pat and developing a bunch of different models. And basically, she's come up with 3 different classes that she annotates and of different, basically CRB damage on these fronds from the imagery that's been provided to us by the folks at University of Guam. We also have some imagery from Oahu, and we have not included that in any of our model building at this point. And so the models we've generated are not based on any of the Oahu data, but lots of model testing, lots of trying different variations, and I can't expect you to see the text here, but basically for these types of things, you want high recall and high precision, and so you want those numbers to be 1, so that you would get 100% of the hits that are out there, and you don't miss any, and you also don't misclassify anything. And so we're not quite at 1 yet, but we're doing pretty well. And these numbers that we see here, approaching 0.9 for recall, and 0.6, 0.7 for precision. So the model's working pretty well, but we always want it to be a little bit better. And what I just showed you were results for all the images put together. These are, if we isolate out imagery from 100-foot versus a model created by Imagery just from 600-foot. And you can see as it's a little bit more coarse resolution, the performance goes down a bit. This is also a function of we don't have very many photos at these different altitudes. And so this talk is really also a plea for folks. We need more CRB damages to train on. So if you have any CRB imagery that you'd be willing to share, I'd be really happy to take a look. I'm going to keep this party moving here. So as I mentioned, we've also got some imagery from Dr. Dan Jenkins, who I think will be the next speaker. There he is, looking great. And so what I'll show you is some results that we're getting from some of these images. And again, these are new images that the model never saw before. So this is something of a test. It's doing, it's doing a pretty good job. So it's picking up this damage. It's missing some things. Here's another example here. Again, we're missing a little bit, but overall, it's picking up the things that we want to pick up. So it's somewhat functional at this point, which is always nice. So we've created, or Tori and Pat have created a detector for frond level CRB damage from high-res aerial imagery. We think that with that, repeat imagery could be integrated into CRB monitoring efforts to complement trapping and roadside surveys. It works pretty well, but we always want it to work better. So we'd like more CRB photos to improve the model from drones, especially photos with a resolution of about 2 to 4 centimeters. That's kind of where we're lacking. And you have any imagery and you'd be willing to share, happy to run it through our detector. We're also working on a way to make it easy for folks to, upload photos online and get the hits automatically. We're working through that. Pat's working on that. But again, if you've got any imagery you're willing to share to help beef up our training data, we haven't been doing this very long, and so I'm happy where we're at. But certainly we'd like to get to the point where you just like Aubrey, have this app and, run it through. But in any case, thank you very much for your attention. This is my email. That's probably the best way to get in touch with me if you would like to discuss this or if you've got any imagery you'd like us to run. So yeah, thank you very much for your time.
Thank you so much, Dr. Perroy, for sharing that. Everybody, you heard the call for pictures, so please get in touch with Ryan if you have any to offer. I have a personal goal of high recall and precision as well, so it's good to know we're on the same page there. I'd like to introduce our next speaker. And again, please put any questions you have for Dr. Perroy in the Q&A or chat. So our next talk is Dr. Dan Jenkins, who'll be presenting remote surveillance and aerial pesticide application for CRB delineation and control. He's a professor of Department of Plant and Environmental Sciences at the College of Tropical Agriculture and Human Resources at the University of Hawaiʻi at Mānoa. Please take it away, Dr. Jenkins.
Oh, thanks, Elliot. And thanks for the nice segue, Ryan. I'm a little more gray hair now, and I'm not going to wear my spectacles, so I don't have to see myself on video. But so I'll try to breeze through this. Actually, you got us right back on time, Ryan. So again, appreciate that. I'm going to talk a little bit about our efforts in terms of trying to automate some of the surveillance, and this is kind of again a lot of overlap with some of the things that Aubrey Moore has kind of described in the first kind of presentation. So I kind of find a lot of ways I tend to be like 5 or 6 or a decade years behind him. But anyway, I'll jump into it. So again, I've been fortunate enough to kind of be able to work with the CRB response team and kind of try to develop technologies to address some of the issues they have, to try to direct more strategic kind of operations to kind of try to keep the beetle under control, and especially in the kind of new incipient populations such as we're having in Hawaii and some of the other islands here in Hawaii. So so the things that I'll talk a little bit about are embedded trap surveillance, and then a little bit about lighting preference experiments. And again, I know a lot of this is sort of just confirming things that Aubrey Moore has kind of demonstrated, and then share some of our results for the aerial pesticide applications using drones. And again, trying to get some crisis use, emergency use authorization, especially for the outer islands where they have new populations, ideally to try to get it under control before it really spreads. So I'll skip the background. Again, I can't compete with Aubrey's excellent introduction and Roland's kind of description of the problem. So again, and I'll kind of race through this as well. So kind of we developed our own customized surveillance system to put in the panel traps. Again, and I'll kind of show a picture briefly, but again, it's basically our little devices have, you know, kind of a miniature camera, GPS unit, cell modem. So all of the communication is wirelessly through the cell network. So it really extends the number of places you can kind of instrument these traps. And then the rest is not that interesting. You know, we do have a little white LED, mostly to kind of illuminate the scene. So you can actually see the beetles at night. I mean, most of these traps, I mean, you're looking at the beetles in the cup, and they're kind of highly overexposed in the daytime. So usually most of the pictures are taken at night. Okay. And again, kind of have this in a custom enclosure and put it in these panel traps, so you can kind of see, you know, where it's mounted, and just looking down into the panel trap and looking at. So it's a pretty simple object detection problem. And all we're doing is kind of automatically, you know, it's most of the time it's in a very low power idle state, and then periodically wakes up, records an image and sends it up to a server. And then somebody online can basically check you know, the contents of that trap and identify whether there's beetles or not. And so again, it's intended to kind of replace really high labor and transportation costs of having, you know, a field crew actually driving around to these traps that are, I mean, those of you on Oahu and probably Guam have seen these distributed pretty much island wide. And we're, you know, I haven't included in this presentation, but my student Mosin who's done most of this work. He's also kind of, right now we're in the process of putting an object detection, so have an automated detection, so nobody even really has to look through the images and classify them. We just automatically generate, you know, we know where these trap sits are. We have a pretty good degree of confidence that it's a beetle, and then just basically generate a map where the new finds are. And ideally, you know, especially if it's in a off, you know, in an island other than Oahu. So we did some validation experiments. These were from last year, so distributed these in some fairly high density, you know, CRB populations, and just had traps sending images every hour, and we're able to kind of, again, confirming that these are kind of crepuscular organisms, so very much most active right after the sunset. So that most of the catches predominantly within 3 hours, after twilight in the evening. I also kind of evaluated artificial lighting. So I originally designed, so these are very simple devices, just little autonomous things, and we can program them to turn on any number of different color LEDs and modulate them, have them flash, or kind of have kind of a wavy pattern or whatever, and then turn on different times of day or night, again, relative to kind of celestial events. It kind of keeps track of daylight hours, and kind of you can program it to turn on different times of night and so on. So and again, so I'll race through this as well, because it's confirming, what Aubrey Moore and, Matthew Siderhurst and so on have kind of already demonstrated. But, again, we've mounted these in panel traps. So these two pictures on the left bottom here kind of show we have custom enclosure. We just use suppose that they call it fluorescent ping pong balls. They're just really thin walled ping pong balls as a diffuser, again, to kind of help it be more visible in a kind of omnidirectional pattern. Mounted these out, had them turn on at night, mostly kind of in the early evening, and then a little bit before the sunrise. Again, most of these, again, kind of did a test trial towards the end of last year out in the Pearl City Peninsula. Just had an array of 16 of these, lights mounted in different positions in the trap. So either up by the pheromone lure, kind of near the top of the panels, or actually in the cup. And then, each one of those treatments had, tests for every different color, and then 2 controls with no light. And I'll skip the ANOVA. I guess, probably nobody's interested in the numbers, but essentially there was definitely an effect. Lighting had an effect. There was some variation in terms of which week we, some weeks just had higher pressure than others. There was no effect in terms of the position. And again, we're rotating the light treatments around these 16 different positions over these 16 weeks. The summary of the results, again, the UV, just like Aubrey Moore kind of demonstrated, is definitely more attractive. Catch more beetles when you've got UV illumination, and preferably up and higher in the panel. And then, that effect is moderated if you actually illuminate the cup kind of down in the bottom of the trap. The other, so again, statistically, there's a very strong effect. I don't think it's important. I mean, basically, a bar farther down in this figure indicates a very strong preference for that color. So UV definitely has very strong attraction, very statistically significant attraction. If we kind of test for repulsion, every other color apparently repels CRB, so don't just put random lights in your trap, or in your netting or whatever, to try to attract the beetles. And so we're kind of trying to develop new kind of new lighting systems, and dedicated lighting systems to kind of supplement, and improve the effectiveness of the traps. And again, as Roland and Aubrey indicated, the trapping, it's not a control operation. Keep in mind, these are really to try to help delineate and identify, where the populations are spreading, so we can kind of prioritize control efforts there. We also did some kind of experimental trials doing the aerial application for pesticides in the tree canopy. And so we're using, several different pyrethroid products. So these are contact insecticides. And again, so we're using a fully American-made drone, again, because there's a lot of areas on Oahu, especially, that have a very significant restrictions based on, federal lands and so on. But we also actually, let me just skip, we did modify a DJI drone, so the Chinese drones, and so Roberto Rodriguez is kind of involved in this a little bit as well, and I'll kind of allude to Timo Sullivan, that they'll be presenting tomorrow in session 4 again. But so again, it's really the only primary reason I put this slide in there is to kind of give you some video of kind of what it looks like. And again, we're trying to get, really have a very precise large droplet, essentially a stream right into the canopy of the tree. right in the crown of the tree, essentially where the beetles are feeding, and not hit anywhere else. Whoops. Okay. So we tested several different products. So Demon Max, it's not labeled for use. There is an agricultural product that has the same active ingredient, essentially Mustang Max, that's labeled for agricultural use. So we tested that as well at least once, and then we used this a product that's classified, and approved for organic farming. It's called Evergreen. I think somebody mentioned it in the chat earlier, and it's a pyrethrum concentrate. So again, pyrethrum is a kind of naturally derived chemical, for better or worse, but from chrysanthemums. So another thing we did, and so for all of our treatments, we removed the fruit and flowers to mitigate harm to pollinators. So we did most of these trials. I gotta keep an eye on the time. I don't want to get us behind again after Brian did a great job getting us back on track. But so he did 2 primary trials in kind of heavily infested areas. One right across the Kunia Road from Kunialoa. If you remember Keith describing that, so the last several years have been really heavily impacted. And then also Ted Makalena Golf Course, which has had kind of a persistent population, an area of persistent population over a pretty long time now. So and so things we were looking for, mortalities. And so one of these things, again, one primary message is this is actually a pretty good tool for delineating kind of populations and active kind of where adults are kind of actually feeding, because they'll drop right out of the tree, within an hour or two of treating. So and then kind of tested to kind of as a way to, again, to mitigate new tree damage and help keep trees alive, and then kind of as a metric for determining the effectiveness of the treatment, kind of looked for depression and nearby trap catches in these treatment areas. So again, it's effective, so these results are basically kind of showing mortality of beetles with different chemical treatments in the trees and different locations. So the different locations, I mean, they're kind of grouped basically similar time, so they should be more comparable in that respect. Mustang Max was a unique treatment by itself. We went back to Hawaii Country Club the year after, when the population had gotten out of control. So it looks like, it's essentially a similar product. We observed a lot more mortality. I think the primary reason is probably there's just a very much heavier density of population density at the time, but it is effective. I mean, it's a good way of identifying whether a tree has beetles in it at the time. Again, I'm not going to show much detail, but over a period of 3 months, I mean, we do have anecdotal data from trials in Kauai as well that they're still having mortalities observed 3 months or more after treatment. So it is protecting trees for about 3 months. Beyond that, you'd either have to reapply or have some other kind of integrated pest management approach, sanitation or whatever, to try to keep the management population under control. And then, again, this data is not as compelling, but if you just look at trap catches nearby where you're spraying trees, there's a decline where you have the chemical control. Okay. So we do have a crisis use exemption again, and I think this is more urgent for the outer islands and, compelling where you're really trying to kind of hope, ideally eradicate, really new populations before it really spreads. We are thinking about evaluating other products with the tank mix. I know Mike Melzer, who he had the recorded presentation, but we've been doing some trials using kind of a soaked burlap just stuffed into the crown, so you're not actually having to spray. We're also talking about having kind of a ground-based application system, and then we're trying to increase capacity both within the CRB response Hawaii here for aerial application. And then, I really have to give credit to Roberto Rodriguez at Hilo. So again, a colleague of Ryan's, and Timo Sullivan, another kind of alumnus from Ryan's lab, who's founded Aloha Aina Drones. So, and they'll be presenting tomorrow, so I won't steal any of their thunder, but I think I'm right on time. So if anybody has questions, again, I really appreciate the support and collaboration from the CRB response people, USDA, the state of Hawaii, and then again, Aubrey Moore. I mean, I really think this is a really great collaborative community. I'm really appreciative of being included. Thank you.
This is Aubrey. Can I ask a question?
Yes.
Okay, it's about your applications. Are they all piloted by a drone pilot, or are there any automated applications being done?
You could, yeah, it's all piloted. I'll leave it at that. Yeah, and it's the primary reason. I mean, you can have some degree of automated flight planning and so on. Certainly in Hawaii, there's enough wind, and the requirement for precision is so important. We really need manual application to kind of maneuver based on the wind and other conditions at the time.
I was going to suggest that you might build with Ryan's work on detecting the V-shaped cuts from the air using drones. You had a drone that could detect the V-shaped cut, then apply the pesticide in place and fly on to the next V-shaped cut.
Yeah,
automate application over a large area that way.
Yeah, that would definitely be kind of an active area of robotics. And so yeah, I mean, I don't think the technology is that advanced yet. And then there's a lot of regulatory issues in terms of having drones not directly attended to, but yeah, that's definitely a good point.
Thank you so much, Dan, for the presentation and all of the testing, and these kinds of cross conversations between colleagues are exactly what we're hoping for. So check that goal off the list. And I want to just say a quick thank you to all the speakers in this session, to Keith, Mike, Ryan, and Dan for your presentations and sharing all of your knowledge. I also want to send a huge thank you to the Big Island Invasive Species Committee for running the whole show here, for their team doing all of the tech, keeping this going despite our initial Zoom apocalypse that happened. Thank you so much to all of you. We do have a poll that we want to share right now. So we could get that going anytime, and then we'll resume our next session in just a couple minutes. So I will turn over the reins to the BISC team. And here it is. Okay, so CRB, in what geographic region are you located? And please go ahead on the Zoom for those questions that just popped up, answer those for us. As well, I think those questions were posted in the YouTube live chat. So if you could please take a moment to answer those questions for us as well, that'd be super helpful.
It says host and panelists cannot vote. Is that by design?
Good question. We'll figure out.
Yeah, unfortunately, that's a limitation of Zoom. Maybe they don't want you to influence the poll too much. But you're more than welcome to put your answers in the chat, and we will record them as well.
Thanks, Franny. For questions and answers as well, we've got the Q&A. I see people are using the Q&A. We've got questions for a bunch of our speakers. There are some as well in the chat, which I think we're recording those, but please, if you're able to put them in the Q&A, that is helpful and a little bit more organized. And feel free to ask questions in the YouTube live chat as well. We'll see those. So take one more minute on this poll. Let us know where you're coming from. And I see answers coming in the YouTube Live as well as the Zoom webinar chat. So thanks so much. And our next session moderator is going to be Franny Brewer. So I'm going to hand over the reins. And thanks again, everybody, for attending, and to all of our speakers and panelists.
All right, I'm just running the poll here, so give me just a second. I'm gonna go ahead and end that and share those results so everybody can take a look. Did we have another break scheduled, Elliot, or are we going right into the next session?
So we have 5 minutes scheduled for our transition. So we've got a couple minutes, yeah.
Okay, so why don't we take another quick break if people want to get a little water, take another bio break, and we'll get started in just a couple minutes. Okay, hopefully that 2 minutes was enough for whatever you needed to do. We're just slightly behind time, so we want to get back on here. Thanks everybody for hanging in. I hope you like stood up, stretched your arms out, get a little air into your lungs. I know it's been kind of an intense, very intense, information heavy afternoon or morning or evening, depending on where you're at listening to us right now. So thanks for hanging in there. And we're gonna jump right back into it with some new exciting talk here from Dr. Matthew Siderhurst, who is right here in Hilo, where I am. He is coming to us from the USDA Agricultural Research Service, the Pacific Basin Agricultural Research Center facility, and he's a research biologist here to talk more about trapping and tracking of CRB. So without further ado, Matt, I'm going to turn it over to you.
Thank you, Franny. So I feel like many of us have been saying, we are the research children of Aubrey and Roland. I definitely have to claim that for myself as well. I think I get to claim that I am one of the elder children, as I have been working on CRB for quite a while. A lot of it actually over in Guam, and not so much of it now that it has been here to Hawaii. So I'm going to be talking about some of the topics that have been mentioned already. I'm going into a little more depth in some of them. Yeah, so both trapping and tracking are what I'm going to be talking about. So three different areas. One, looking at CRB attractants. So a little bit about what's been done in the past. And my summation on this real quickly is, unfortunately, we have not been real successful in finding things that work better than Oryctolore. We already had Dan talking about the UV lights, just a touch on where that came from. And then I want to spend more of my time talking about the Judas beetle technique, or the Judas technique in general, as a way to potentially track CRB, figure out where their breeding sites are, and how we could use this technology to find them and eliminate breeding sites. So again, I will plug the whole importance of interdisciplinary research here. This is CRB is something that I got started working on way before it was in Hawaii, and working on it in Guam. Obviously, it got here. So as proactive as we can be, and as much as we can share information is a great thing. So a little bit about attractants. So the attractant that we use at this point is Oryctolore. I will try to keep my chemist hat off for the most part to not scare people away too much here. This is not the first molecule that we had for the attraction of CRB.
Hey,
It is the
Matt,
most,
if you're
yes.
trying to share, the presentation hasn't come up yet.
Ooh, that is a trick. So it looks like it is up for me. Why is it not up for other people?
Go to your Zoom screen, because Zoom is doing that weird double thing, and just hit that green share button.
Yeah, I've got a little thing that's running around my I will try again. And of course, this is why we practice, and then we have problems with it. All right, so
Perfect
let me try this. Let me try this again. So when I say share, I should be able to do screen 2, share.
Looks like it's coming.
Okay.
Yeah. And now we just need presenter mode, and I think we'll
Yep. There we go.
Beautiful.
All right, does that look better?
Absolutely.
That was me trying to get ahead of myself and have it up before the break, and maybe that was the issue there. So we're all good at this point, I believe. Let me get so I can see a clock too, which is a needful thing, so I don't run a little longer. The thing that kind of kicked us off on looking at attractants is, as Aubrey talked about, the fact that there was a lot more damage on Guam than the trap catchers would suggest. And so we were interested in going back in and seeing about what the possibilities were for trying to find new or better attractants. One of the things I will mention as a chemist here, there is the possibility of chirality in Oryctolore, and this is not something that has really been looked at a lot. It's one that I would like to go back in and see if looking at the chirality of this molecule is something that can get us better attraction, especially with knowing that we've got different beetles than all over the place. So attractants, the place that we were looking was really at either at the beetles themselves or at the palm trees. So here we have this is Roland back in the day. This is me when I had more hair. And we were actually doing things like bagging an entire coconut tree so that we could collect the volatiles off of it. Lots of different coconut parts that we brought back into the lab. This is all happening in Guam. What we did was we used a bioassay that was glass, a Y-tube bioassay, very kind of classic thing. And we were then looking for what the beetles would tell us about what they were most attracted to. So on this graph here at the side, then what you can see are the dark bars are when we have a beetle that's going towards one of our treatments, and the other side then is a negative control. So you can see that the things that are most attractive here are the coconut crown itself, and Oryctolore is the lure that we're using. So initially, very promising. One of the problems here, though, is that if you're trying to attract with something that is a natural material, well, how do you overcome the attractions that are just there from the coconut in the background? So the next thing you need to do is take these materials and run them through some sort of analysis to be able to find out what the chemicals are that are attractant in there. So we actually sent one of our GCEAD systems down to Guam, as well as doing some of this work in Hilo. So we had an importation permit, and we're bringing beetles into quarantine and using them here. So a number of compounds that were identified as being attractive, and then we ran those back into our bioassays. The compound that I am most interested in is actually this one at the top, cyclosadovine, one that appears to be a really nice attractant for us. The problem is that it is not commercially available, and I have not figured out how to make it in mass quantities yet for us to be able to use. And really the take-home message here is that we have not found anything better than Oryctes. We had a shot and it hasn't worked real well. We have also worked with a number of USDA colleagues from APHIS and other places who have continued this work. We switch over to the lights, which actually Dan talked about carrying on from the work that we had done initially in the early days. So this was, again, a discovery that we actually had here in Hawaii with looking at the beetles and how they were interacting with our lights. So I love the fact that Dan has carried on with this. So these were some of the initial traps that we had. We were sending Aubrey bankrupt by using all of the batteries that we used initially. Here's some of the initial field testing that we did back in the day. We actually had a combination of looking at reduced lures and standard lures at the same time that we were looking at the UV light. Here the UV light is pulled out, and you can see that it is it's quite helpful to us. We're getting somewhere between 1.5 to 2 times the amount of capture when we're using those UV lights. And the thing that Aubrey went and did then was to get rid of the need for those batteries and to hook this into just like your porch light or your front lawn light, where we have a photovoltaic cell on here, and then replacing the LED that's in there with a UV LED. We were actually working in about the 400 nanometer area, so not quite as short as some of the ones that Dan was showing, and this ended up being quite a nice pickup for us. So those are kind of aspects of things that did or didn't work, worked a little bit, or in the case of the traps, that was quite helpful to us. I want to move on now into a technique that we tried in Guam, and by the time that we had it working in Guam, was probably not going to help with their population suppression there, because the beetles were all over the island. I think that this is a technique that could potentially help when we have very small populations at the beginning of an invasion, and a way that we can potentially help with control at that point. So we thought we were very clever in coming up with the idea of Judas beetles, and I'll explain what this is. As we got into the literature, we found out, oh no, people had come up with this very same even reference to this biblical reference to Judas before we got into it. The genesis of this was that on Guam, there were dogs that were being used to find where we had infestations of the coconut. And what we were hoping to do then was, as opposed to using the dogs, so dogs had to work on leash, you had to return them to the truck, right? They're expensive to use. Can we actually use conspecifics, right? So the idea here is that you are using, in our case, the beetle itself to tell us where are other beetles and how can we go find them. So this is something that it's been used for birds, it's been used for fish, it's been used for mammals. Actually, Judas goat is kind of where the idea comes from originally, and some of that work was pioneered here on the Big Island. Even in snakes, which scares me a little bit to see something that size. The idea in all of these cases is that you put some sort of tracking device on the organism that you're interested in, let it go, and if they are social, or if they have aggregation as part of their behavior, then that can lead you to where those individuals are in the environment. So we've used 2 different technologies for this. So the first is radiotelemetry, and I'm going to mostly talk about radiotelemetry. There are some real advantages to this. The downside is it's expensive. Harmonic radar, which is something that we've been working with more recently, is a lot cheaper, and I'll kind of hit this here at the end. So how does this work? What we were doing this work in Guam. We would catch beetles. We would set off at night then. I love doing this. Aubrey had a great IR camera, so we could see when our beetles were heating up, when they were ready to go. They would take off, and then we would chase them as far as we could, get a bearing on them at night, come back the next day and see if we could find them. So here's an example of a beetle that we found that was buried into the ground. So we could actually find lots of different locations. So these are the two locations that we worked in with this technique. So one by the ocean, one on an agricultural farm. The yellow dot in the middle are the two release sites where we were releasing beetles from. All of the red spots are ones where we confirmed a beetle location. The green arrows are places where we lost a beetle, but we had a range on it. We had an idea of which direction it was heading into. So some of these green arrows are there because they went into areas that were swampy and we couldn't get into, unfortunately. If you look at what happened to those beetles that we released, one of the things that's very striking about this is that none of them went to Oryctes traps. And all of these areas have lots of traps in them, and we're just not getting beetles going to those traps, which is again a confirmation of what Aubrey was saying about how the Oryctes is just not a great attractant for these beetles. So the places that they did end up, a lot of them ended up in trees. There were also ones that ended up in the soil. One of the things that we found that was really interesting out of this, and how do you know what the beetles are doing until you actually follow them around in the environment? This was, and I'm going to forget, I think that this was dolphin that we were after. And we actually tracked a beetle to a damaged breadfruit tree, which normally you would not expect breadfruit to be a host. But it was damaged, and as we had a guy shimmy up the tree and look in there, sure enough, we had a breeding site that was in a broken part of the tree. Obviously, something in a tree is not something that a dog can climb up and sniff out. But with using beetles, this is the sort of thing that we can follow them to where these breeding sites are. The idea would be that, if we can catch beetles, we can put a tag on them, we release them, we find where these breeding sites are, and we take them out early. And we can get cryptic breeding sites. We can try to figure out where, trying to get all of them out. Obviously, if you've got beetles all over the landscape, this really isn't something that helps you a whole lot. This is more, again, like I said, the early part of the invasion. So coming back to the technology that we're looking at here. A number of different ways that we track insects. I'm actually involved in tracking lots of insects with different technologies. The one I don't have on here is Bluetooth, but radio telemetry really is the longest and strongest tags, but they are very expensive. So about $300 a tag, and they don't last very long. There's a German company which is now making rechargeable tags, which I think would be a nice thing to get into. I don't have any of those in my hands. This harmonic radar, though, is a technique where you don't have quite the range, but they are super cheap. Really, the idea that Aubrey has been putting forward with this is that we're not trying to track individuals, but we release a whole bunch of beetles that have a bunch of these cheap tags on them. That gives you a real hot spot in the environment that you can go and track these beetles down to. Unfortunately, the issue is we've tried this in Guam, is that our tags are not quite strong enough for this yet. So this is where we have been back to the drawing board. We've been working on trying to make stronger tags and working on the attachments that we have. If you think about what a CRB is doing in drilling into the top of a coconut tree, that's a lot of force on the tag that we put on a beetle, and we need to make sure that stays stays there. So we now have this beetle on the Big Island, right? So it's actually in my backyard. So I'm like, boo, it's not here, or I don't like that it's here for that reason. But this is a potential for us to be trying to apply this technique to it. So this technique has now been applied very successfully to wasps. So you may have been hearing about like the murder hornet coming in to the West Coast. This technology has been used for those wasps. We've actually been developing it with wasps and colleagues from Florida who are interested in having it as a technology there. I would love to do it on Koki. We have colleagues in Australia that have put this is not Koki, but another small frog. Not so much Judas there, but following them around in the environment. So an interesting technique that I hope will have some input for us. Thanks here. Our funding has come from a variety of sources, Forest Service, Hawaii Department of Agriculture, USDA, a bunch of students and USDA people have helped with these over the years. So I think I am just at time. I will sign off.
That was amazing. I still am baffled by people who are able to put little radio transmitters on these tiny, tiny insects. Just amazing work. Thank you so much. If folks have questions, please go ahead and put those either in the chat if you're on YouTube, or you can do that on the Q&A on Zoom. And we're going to go right ahead into our next presenter, Andie Ledoux. She's an undergraduate student at UH Manoa studying natural resources and environmental management. Andie, you want to go ahead and share your screen and take it away when you're ready.
Awesome, thank you. Hopefully that looks good for you all.
Looks great.
Awesome. Okay, hello everyone. Like Franny mentioned, my name is Andie Ledoux. I attend the University of Hawaii at Mānoa, and this is a project I did with NOAA and the Hawaii Department of Agriculture that we're calling Protecting Moananuiākea Mules, the effects of weather-inflected CRB on Pacific Islands food insecurity. So with that, I wanted to start with an olelo no eau. For those of you from Hawaii, you likely know what this is. If you're not from Hawaii, these are Native Hawaiian proverbs or wise sayings. And I think they're fun because they can teach us a lot, not just about ourselves, but about the environment. So this is 2706, and this is Pu ali o ka hau nui a ka hau iki, which means do not underestimate the small guy. So I think it's kind of funny because CRB, though they're big for bugs, you know, they're small in the context of the environment, but obviously the reason that we're here is because they have a big impact and we're learning that. But also, I think if we look at this in a wider context, I really appreciate everyone that's here, not just presenting, but also in the audience, because obviously this is a big issue that we have to combat. And I think oftentimes working in the environmental science field, it can feel like our individual impacts aren't enough, and that we're only making a small impact because there's so much to do. But I just want to remind everyone that, you know, though you might be small in the context of everything, your impact that you're making is really big. And so I just want to mahalo you all for that. And so I'm also going to jump into just a little bit more about myself. So like I said, my name is Andie. I am from Kapolei, Oahu, Hawaii, and I attend UH Mānoa. I am a senior in my undergrad, where I'm studying natural resources and environmental management. I'm also a part of the NOAA Educational Partnership Program with Minority Serving Institutions undergraduate scholarship program. And that was kind of the driving factor for this research was as a part of that program, I was instructed to conduct academic year research and about something I was really passionate about. So I was, you know, thinking about my passions, and I've always kind of had an interest in agriculture. And so I got the opportunity to intern at the Hawaii Department of Agriculture with the help of Dexter Kishida, who is the deputy director. And so this was kind of a project that he and I came up with together. So in kind of coming up with this project, I was thinking about my personal interest of food security, and then also what are the threats to food security. So we know that climate change is a really pressing issue in Pacific Island communities. And we also know that invasive species are a huge issue globally, but also in Pacific Island communities. And obviously, one of the most prevalent invasive species that are getting a lot of attention right now is CRB. And that's why, you know, we're all here. And so in looking at CRB and weather or climate change, big natural disaster events, I was wondering, you know, is there a correlation between CRB spread and the weather? And if there is a correlation, does it directly affect food security? So this project, you know, is maybe a little bit more of a discussion, or this presentation is maybe a little bit more of a discussion from the other ones that we had today. It definitely belongs in this emerging science category because it's kind of, you know, something new that we've not been working on for too long. I think it's been less than a year that we've been kind of discussing this, but I just hope this presentation gets you all thinking, because, you know, for me, I'm 20 years old, I'm young, and these issues are going, you know, the issue of CRB, if not treated, is really going to affect my generation, Hawaii's food security, and, you know, my future children and their grandchildren. So I think all of us, right, we have this personal connection to wanting to combat this issue. And so I just want this presentation to kind of serve as a way for us to start thinking, how could these things be correlated, and how can we get research started so that we can hopefully combat these issues? So how could CRB threaten Pacific Island food security? I'm sure a lot of us are familiar with this, right? But coconut rhinoceros beetles do not only target coconut, they are also known to target kalo or taro, sugarcane, pineapple, banana, some other food species as well, but then also trees such as lolu and hala, which are, you know, trees commonly found here in Hawaii. And I mentioned lolu not because it's a food species or a food source, but because it is the native Hawaiian palm. And so though it doesn't maybe contribute to food security, it has a high ecosystem value and a high cultural value. So not only is CRB, you know, going to affect food security, but it's also affecting ecosystems and very important cultural species. So in thinking about how CRB can spread from the weather, I kind of divided it into two areas that I had questions about. So there's severe weather and natural disasters. So examples of these would be high events such as typhoons, tropical storms, and hurricanes. But then our standard weather patterns are our day-to-day weather. And an example of this would be the daily wind patterns in a specific area. So first, looking at CRB spread from natural disasters, I broke it into two different effects that natural disasters could have on CRB spreads. So this is high winds, which is the first one, which would be a direct effect, right? This is while the weather event is happening, there could be high winds. For instance, in some of these typhoons or hurricanes, right, we see winds of up to 100 miles per hour. And if a beetle were to become airborne in this instance, it could carry the beetle a long distance because these beetles are not known to be super strong flyers. However, the probability of this causing widespread destruction or spread is unlikely because CRB are usually burrowed inside of the trees. Yeah, they're not typically climbing all around the ground, but if they were, this could potentially cause spread. However, then there's the secondary effect, which I think a lot of people have touched on today, which is great, and that's the green waste or the decayed vegetation, because we know that these beetles feed heavily on decayed vegetation, and this is great breeding ground, and that's what causes like this huge explosion or boom of CRB spread. So the probability of this is a lot higher due to the natural disasters, production of lots and lots of green waste, and then obviously the cleanup from these natural disasters. And so when I'm thinking about natural disasters that could potentially be studied in the future for this could be like Typhoon Dolphin and Typhoon Mawar, which both happened in Guam, right? So these are big natural disasters in an area where CRB is already prevalent that could be contributing to CRB spreading more. And I'm grateful that Dr. Moore touched on that earlier a little bit. So then let's look at standard weather patterns, right? So I'm going to use Oahu as an example because I am from Oahu, but a very common thing here, right, that we talk about all the time in Hawaii is the trade winds. And so the trade winds come from the northeast and they blow in this kind of direction, yeah? And then if you're thinking of them blowing things, right, an idea is that a lot of them would end up in this kind of southwest corner of the island. This area is called Honouliuli, or Nanapuli is a little bit up here as well in Waipio, but the majority of that area is the land division or the Ahupua'a of Honouliuli. And with the maps that we saw earlier of CRB detection, this area also coincides with high CRB detection. Like this is a huge hotspot for CRB. So why is this an issue? Honouliuli is home to a couple really, really important sites. And so one of this is the new or coconut grove at UH West Oahu. Some of you may be familiar with the initiative that they have to, you know, restore new groves, but also to protect the genetic diversity of coconut. And this, the UH West Oahu campus does fall within Honouliuli. And then you also have Pu'uo Kapolei, which I am from the town of Kapolei, and the town of Kapolei gets its name from Pu'uo Kapolei, which is a wahipana or a storied place in Hawaii. And there, as you can see in the photo, there is a good amount of new trees or coconut trees in or at Pu'uo Kapolei. And as of last February, it was detected that every single coconut tree at Pu'uo Kapolei had been infested with CRB. So this is not only an issue for food security, but it's an issue for culturally significant spaces. So I'd also like to shift our attention to looking to the past, because I think looking to the past can give us a lot of answers to the future. So this is the Hawaii Territory Survey, and this came out in 1902. And I want to just preface that this is not traditionally exactly how Hawaii was, right? Because 1902 is obviously post-contact Hawaii, so there's already going to be land changes than what it's significant or than what it originally was. So, you know, this map also encompasses like the sugarcane plantations and things that weren't originally in Hawaii pre-contact. but this map also does a good job of showing areas that have different types of agricultural development. And I think that this is really important because as we talk about food security and strengthening food security and, you know, restoring areas of high food production across the Pacific and across Hawaii, we don't want to just build a farm or build a lo'i or a wetland taro cultivation area in a space that it didn't previously exist, right? Because there are spaces in which this was done and it was successful. And for that reason, we want to, instead of picking a totally new area, we want to pick an area and restore it to what it once was, because that area is known and it has the ability to, you know, feed the communities. So this map shows in the blue, which I've kind of tried to circle, different wetland food cultivation areas, primarily for rice and for taro or kalo, which is a huge sustenance food across the entire Pacific. And so this map does a good job of showing us where exactly lo'i were. So you see a huge concentration of them on the windward side of Oahu, the east side. You see another concentration down in the Honolulu, Waikiki area. You see some surrounding Pu'uloa or Pearl Harbor, and then you see a couple in the North Shore, Haleiwa, Waialua area. And so this is important, right? Because if we're trying to, again, restore lo'i, then these are areas that we don't want CRB to spread because we want to be able to produce as much kalo or taro as possible. So how do we apply all this previous understandings and use these ideas to create research and to create answers or maybe new ideas of how we can combat these issues? So the first thing is we need to have CRB data, which a lot of people here have, which is fabulous. Especially like Mike Melzer, he's helping me a lot with this project by offering me the data from his lab. So there's both pheromone trap detections and then also palm frond damage detections. And so using those together, we can pinpoint like some of the graphs that were shown earlier where exactly CRB is. And this doesn't have to just be in Hawaii, right? This can be applied to all Pacific Islands, just knowing where the CRB hotspots are. We can know then where the agricultural hotspots are located. So like I said, it's important to look to the past to know what areas we can restore for food production, to up our food security and to try and keep CRB out of, but also we need to know in the present day where the agricultural hotspots are located. So knowing where is food being produced, where are the farms, where are the lo'i, where are the wetland food areas, all of that. Then we need to know specific storms and high wind events. If we want to see, is there a correlation? We need to pick specific storms, high winds events across different Pacific Islands. And then using GIS, right, we can look at the detections leading up to the storm. And then after the storm, see, is there a boom that could potentially be linked? We can also use GIS to then take those CRB detections and plot it over where the agricultural hotspots are located to see that overlap and see exactly how CRB might be able to attack the food being produced in those areas. And so that's kind of the area that I'm in right now. I'm still kind of rocky at GIS, but I'm working on it. And then we can apply this across not only Hawaii, not only Guam, but different Pacific Islands. And so with that, I thank you guys for listening. These are just a bunch of questions that we've kind of been coming up with and things that, you know, we'd like to answer. And I just hope to get you guys all thinking about different ways this might be affecting our communities. And if you ever want to chat, my email is andie30@hawaii.edu. So mahalo, you guys.
That was great, Andie. Thank you so much. Folks, you'll notice, oh, Andie, I was gonna say, Andie has her email there, but maybe you want to type it in the chat. So
Yes,
folks,
sorry. I'll put it in the chat.
That'd be great. Reach out. Really appreciate that you sharing that information. That was really interesting, and I like your approach. So we're gonna, I think we're doing really good on time. You actually helped shave off a couple of minutes there, so appreciate that as well. And we can move into our final presentation for this day. So again, thanks to everyone for sticking with us. We now have Elizabeth Spieth and Arissa Barcenas coming up. Elizabeth is the facilitator of 643pest.org, which is the invasive species reporting tool for the state of Hawaii that's run by the Hawaii Invasive Species Council. And Arissa is an outreach associate for the Coconut Rhinoceros Beetle response at the University of Hawaii over there on Oahu. So both of them have been very involved in communications around invasive species, in particular, particularly CRB. And I got to participate a little bit in the development of this plan, and I can attest to how much work went into the development of this communications plan. And I think the work that they did, the outcome was really great. So I'm not sure, Elizabeth or Arissa, who's going first, but you can go ahead and start speaking and sharing when you're ready.
Mahalo for that introduction, and I am going to share the screen, hopefully the full screen. How does that look, everybody?
Looking good.
Mahalo. So once again, I'm Elizabeth. I'm joining today from the island of Maui in Hawaii. And Arissa, we both will be kind of tag teaming, talking a little bit about this statewide coconut rhinoceros beetle plan that we've made here. So we're going to start off with a brief update on the CRB situation here in Hawaii. There's a lot of the previous, and mahalo to all of the speakers today. It is so amazing to hear what everybody, all of the work that has gone into CRB across the Pacific. But we're going to be able to get everybody up to date. And this is a little bit of a gear change from what we've been talking about earlier. We're going to get up to date with where CRB is and is not in the state of Hawaii. And then we're going to delve into the CRB communications plan, the reasons why it was created, who contributed, the sections of the plan, and some of the priority stakeholder messaging. And then we're going to give some examples of engaging with diverse perspectives on CRB management. So Arissa will start it off with those status updates. Oh, hopefully I can, there we go, because I'm driving. And so Arissa, just please tell me next whenever you're ready to go to the next slide.
Perfect, thank you. Real quick, we're just going to give a quick update. CRB was first detected in Hawaii on Oahu in 2013. And for about 10 years, it was contained to Oahu until just last year when we had the first detections on Kauai, Maui, and Big Island. Next. So here, many of you might be familiar with this invasion curve. But this depicts where each island is in its response to CRB, which has impacted the specific messaging laid out in the document that we created. So this invasion curve, it just provides a more structured framework for addressing invasive species such as CRB. And where each island is on this curve is going to depend on a few factors, and the response activities and messaging will vary in each phase. So many of you might be familiar, but I'll just quickly go over for those who might not be. But prevention is going to serve as the initial line of defense, and this is where Lanai and Molokai are, since they have not had any CRB detections. I wanted to note on this curve, all of Maui County is grouped together, but Lanai and Molokai are still in that prevention stage. And then once CRB is detected, eradication efforts are then deployed. And so this is the stage that Maui and Big Island are currently in. And activities in this stage are going to focus on early detection and rapid response. And then once there's a rapid increase in population and spread of CRB, there's this shift into containment where the activities are going to focus more on restricting population expansion. And so this is where Kauai is. And then finally, as the infestation grows and spreads, we shift more into this long-term control and management, which is the stage that we are in on Oahu. And since CRB is such a critical topic and each island is in a different stage of infestation, we created this document as a guide for communication about CRB at a statewide level. And so understanding where each island is on this curve has helped to create this tailored guidance. So I'm going to hand it over to Elizabeth to give an overview and more on the goal of the document.
Mahalo, Arissa. So like Arissa was saying, as CRB started to spread outside of Oahu and more partner organizations became involved in the different aspects of early detection surveys, mitigation and control efforts, fielding reports from the public, identification, as well as outreach efforts, we decided to take a cue from a successful approach here in Hawaii with a kind of similar pest, the rapid ohia death. So rapid ohia death is a fungal disease that impacts one of our native trees, the ohia, which is a keystone plant tree, of our native forest. And ROT is similar to CRB in that each island has a different situation with levels of infestation and multiple different partners involved in that management. So For rapid ohia death, DLNR and partners working on ROD created a statewide rapid response plan and a communications plan. So this is a complement to some of those plans like Dr. Moore mentioned at the beginning and shared the link to. This is a complement to help us all come together and provide guidance on priorities for all of the islands in all of their different situations. So we wanted to be able to include the input from people from throughout the state. And as Franny mentioned, there was a whole bunch of different people. Almost every island in the state of Hawaii was represented. We met almost weekly for over 6 months. It was a lot of input, but it was really essential that we were able to encapsulate those experiences in specific situations. It's very different on every island in Hawaii. So to that end, we created this guide, which has essential information, tailored messaging for the diverse audiences we identified. And specifically, there's 9 high priority stakeholder groups. And there is a link that you can go to, because we're really going to just go over this briefly. We're hoping that throughout this presentation, we can just give you a little teaser. And also it's a living document. So we're wanting to solicit your experiences to be able to incorporate into future versions of this document. So as we've been talking about, it's a totally different situation for each of the islands in the state, with not only how many CRB are there or not there, as well as the communities that are there. But just to keep it kind of simple, we divided the island groups into infested and non-infested islands. So the messaging will be a bit different for each of those. On infested islands, the focus is on mitigation and control efforts, or sanitation, as they keep talking about today. While on non-infested islands, the focus is on prevention, early detection, and rapid response to prevent establishment. Now, as mentioned, Arissa will give some more teasers. She'll talk about all the different sections that are in the plan. And you're muted though, Arissa, sorry.
Thank you. Yeah, so some of the sections that we included in the CRB communications plan include identification of CRB, different primary and secondary food sources, as well as high-risk material, so places where CRB might be breeding, as well as different signs to look out for to identify CRB infestation. And then we also have information in this plan about early detection tools and management. So a lot of information about traps for early detection and monitoring, as well as info on community trapping programs, which we'll talk a little bit more about later. And then different management techniques, as well as how to handle the CRB specimens and report CRB infestation. Okay, and then lastly, at the very end of this plan, we have some resources. So that includes things from video links and articles to contact information and toolkits that can be used for outreach. So I'm going to hand it over to Beth again to introduce one of the major portions of this comms plan, which was stakeholder messaging.
Mahalo, Arissa. And as mentioned, as this whole group convened over all those months to talk about how we could have essential information and really target our communications about CRB, we came up with 9 key stakeholder groups that we thought were important to prioritize. You can see those groups right here, the general public, of course, because we get a lot of our reports, especially on islands with low to no infestations. We're really looking to the community to be helping us keep an eye out for CRB infestations. Landscape professionals, which will show you an example of how the messaging was created for that group. Retailers, green waste and compost facilities, farmers, cultural practitioners, golf courses, maintenance staff, and this includes also managers of large land holdings, botanical gardens, and the military. And so this is kind of an overarching, this is an example of how we broke up some of this, how for these messages for the general public. There is information inspecting and reporting, managing high-risk materials, so that's sanitation, staying informed, and prevention. And as mentioned, this is kind of or maybe not mentioned, but this is an overarching guide for all of us working in all these different groups and different situations to have a touch point to make sure that we are including the same information and we're not missing anything when we're talking to all of these different audiences. But what we give to the general public is going to be different than for some of these stakeholder groups. And Arissa will take you through one of our groups, the landscape professionals.
So landscape professionals were identified as one of the key stakeholder groups, and this is due to their frontline role in detecting CRB and preventing its spread. So for each stakeholder group, we identified the justification of why they were identified as this stakeholder group, as you see here. Next slide. Perfect. Okay, so here we see the general layout of messaging for each stakeholder group. So it's divided into messages for infested islands on the left and uninfested islands on the right. There are some differences between the messaging for infested and non-infested islands, such as reporting guidance, and there are, of course, some similarities between both, such as management of green waste. So these specific messages have been helpful, especially in outreach and communicating to these stakeholder groups and being able to incorporate these messages into different presentations and trainings and making sure that we hit all the most important action items when we go out to do this outreach. Next.
All right. There we go. I think it's back to me again. So we wanted to give a couple of examples and perhaps solicit from this incredible audience some examples from you too. But sometimes trusted voices in our communities may share information about CRB management that differs from the quote unquote official guidance. This is often based on their own experiences and understanding, which can be valuable, but might not always align with our shared plan. Rather than seeing this as a problem that needs to be fixed, it opens up an opportunity for conversation. And by engaging in open dialogue, we can build trust, clarify concerns, and work together towards the most effective solutions. So we've experienced these kind of varied voices coming from our community in a lot of these different examples. So detection traps, treatments, pesticides, which is, it can be, pesticides are serious. I'm not trying to make light of any of this, but these are definitely areas where there can be multiple voices with different values and experiences coming forth. But we really wanted to delve into an example that we have, and we've been hearing a lot about today, but we're going to talk about these traps in a slightly more specific context. So one example that we're wanting to highlight is the use of those commercial CRB panel traps for early detection and breeding site identification, excuse me. These traps are a critical part of our early detection strategy, and without them, we would be relying only on visual detection of the tree damage, which can take months in order to be, for those fronds to emerge and for them to be spotted, or for people to regularly self-inspect potential breeding materials like green waste, compost, even raised garden beds. That includes sifting completely through these materials often to find larvae and tiny eggs, which is like finding a needle in a haystack. And this is a significant ask for any community, as well as in that time frame, that several months, you could potentially move those materials to new places. So especially on the non-infested or lesser infested, where there's just been detections of CRB, just one or two, such as outside of Oahu, the Island Invasive Species Committees have created a community detection program where community members install, monitor, and maintain what we're now calling detection traps in their own area. And so these detection traps are then checked by the community, and they upload or share information, which is then aggregated along with agency detection trap data, which is often clustered around high-risk areas on these uninfested islands, to ensure a comprehensive and reliable network of detection traps. So some members of our community have expressed concerns or confusion about how the traps function, particularly around the belief that they might be attracting CRB to new areas. And we've heard a lot today about how they're looking for new lures, like we just were hearing about, as well as when Dr. Moore was talking about how these traps are not the most effective thing ever for controlling. And that's why the emphasis with these programs are for monitoring and early detection. So you guys have seen how the traps work, and you've been hearing about how the lures are attractive. And it turns out in our field experiences here in Hawaii, in Hawaii, we've been seeing that the traps are much less, up to 26 times less attractive than green waste and palms. And the attractive range can be anywhere between 5 to 50 feet, depending on weather conditions and site conditions. So with all of those caveats, I told you why we're using them, but here's a lot of caveats. Why would we use the traps? And Arissa is going to give a couple of examples of how the traps have been effective and how our experiences in the field have given us those numbers about what their ranges are.
Thank you. Yeah, I think we're running short on time, so I'll keep this real brief. But we pulled some stories from Hawaii of where these traps were placed, and trapping was limited and then detection was delayed. So the first example we have is on Kauai, where the first detection of CRB occurred in a trap by the airport. And after setting up traps following that detection around different areas on the island, the new traps immediately detected CRB, signaling that multiple infestations were already established across different areas. And then another example that we have is on Oahu. And so we can go to the next slide. Perfect. Thank you. And so this example is on the windward coast of Oahu, where traps were deployed and for years did not catch beetles. After we got a tip from an anonymous tip, we then surveyed this farm that was suspected of CRB infestation. And after inspecting the farm, or after surveying the farm, we found that CRB had probably been present at the site for a couple of years. But prior to that, the closest traps were about 1/2 mile and 1.5 miles away. So again, another example of the traps being too far away to actually detect CRB. So these stories we're kind of using to highlight the need for comprehensive trapping networks, especially for early detection of CRB and the limited range that we're experiencing with the traps.
Okay, and so mahalo, sorry if we went a little over, but we are actively, this is a living document, and we really meant it when we want to get your experiences from the field so that we can incorporate that into how we are communicating and dealing with CRB in Hawaii. So mahalo, and I think every other time I'll stop sharing.
You're fine. That was fantastic. Thank you so much. And are you asking, Elizabeth, for people to email you with information or feedback, or how would you like that feedback?
Absolutely. I'll include both Arissa, who is with CRB Response, and my email. But you also can go to the CRB Response webpage, and almost any communications you send through them, Arissa will see.
Wonderful. Thanks so much. Well, that actually brings us to the end of our day, or maybe it's midday for some. Again, some people are getting ready for bed because we really did have such a wide geographic range. So appreciate all of our presenters. If everyone knows how to use the react button, you can go and give them a heart or a wave or a thumbs up or something, just to let them know how much we appreciate the work that went into not just the work itself, but what they have done to bring that to us and share that with us, and the effort that was put in. We appreciate it so much because we're all dealing with this and trying to learn more about CRB and how to manage it. We do have a big day 2 planned tomorrow. There were many questions that were shared today in the chat, the Q&A on YouTube. Our team has been furiously typing away, copying all of those questions, making sure that they're getting to the folks that they need to get to. And we hope that you can join us tomorrow at the end of the presentations. We're going to have a panel led by Christy Martin of the coordinating group on alien pest species here in Hawaii. And hopefully most of our panelists will be able to attend that as well and answer a lot of these questions, especially ones that came up regularly throughout the day. So once again, really appreciate all of you being here, and we hope to see you all tomorrow, same time. We're going to do it again. Use your same link, and hopefully we'll figure out our Zoom issues, and we won't have to do YouTube. But if Zoom is not going to be cooperative, then we'll have YouTube going again tomorrow as well. Thank you so much. Aloha.